Welcome. Can you guys hear me? All righty. Yeah, sorry about that sound check. Okay, so we should be good. Welcome to the Pacific Region DevFest 2020. All righty. So we're using StreamYard this year to do our virtual DevFest. If anyone has any technical difficulties, please log a comment in the chat on YouTube. We also have a question form that you can use if you need help too. I'll go ahead and bring that up right here. There we go. So if you have any questions today, feel free to use this URL. And this will be available throughout the event. We'll be using this for questions, not only general questions, but also for each of our talks. If you have a question to one of the speakers, you can fill out this form, and then we'll ask it to the speaker when they're done with their talk. So again, welcome. My name is Matt Kaufman. And here we go. Today's a special event. This is the Pacific Region DevFest, and we have 9 different Pacific Region chapters participating. I'm Matt. I'm a community organizer here based in LA, but everyone is welcome to this event regardless of where you are around the world. Before we begin, we're going to go through some housekeeping. So this is our code of conduct. We'll also have a link to it right here. There we go. So you can review this at any time. That same question form can also be used if you have any concerns regarding the code of conduct. Feel free to use that form as well. We'll be actively monitoring it throughout the event as well as afterwards. But as always, please be excellent to each other. It's a little easier now that it's a live stream as opposed to something that people can talk on. But even with the questions and comments, definitely this still applies. If you see or hear something, speak up. Some of you already know how to reach me. You can reach me that way. But again, the question form is totally appropriate too. There's nothing wrong to say on those forms. Let us know anything that concerns you. This one's important. Practice saying yes and. It's a lot easier to say no, but some of the best ideas come from collaboration of diverse teams. And so saying yes and can lead to those amazing ideas. Zero tolerance. So again, let's try to keep things friendly and be excellent. So even a funny joke is not funny to everyone. So better safe than sorry. Zero tolerance policy for any kind of harassment at all. Even if you didn't intend it, it still can be perceived that way or received that way. So let's just avoid it. And there's so many different things that can offend people. So again, it might seem funny at the moment, but later on it wouldn't. So, play it safe. Keep the comments clean. Again, this is available at the URL. So if you want to read it or even use it for your own events, I'd recommend it. So I mentioned earlier, this is a special event. We have 9 different GDG chapters in the Pacific region, all the way to Hawaii, in fact, participating today. And this has never been done. We've had a couple other region-wide events, but none like this. So thank you all for attending. This is also being live streamed. So it's available on YouTube right now, but you can also watch it later. For our fellow chapters, it'll hopefully be published on their YouTube channels as well. Again, if you have any questions, this URL is up, bit.ly/devfest_Q. I believe bit.ly is case sensitive, so be sure to get that. We are also checking the chat, but if you wanted to submit an anonymous question or anything like that, this form is essentially anonymous. It won't be seen by others. And we'll also be showing this question URL throughout the talks today, so you don't have to necessarily write it down. We'll periodically show it as well. All right, with that, let's bring in a special guest today. We have Kubra from Google. She's the Developer Relations Program Manager for the GDG program. And she's a great friend to all of us and a wonderful speaker. So we're lucky to have her today.
Cool. Thank you.
Welcome.
Thank you, Matt. So this is great. Hopefully, all you. Yeah. I'm really excited. First of all, I would like to say this because this is the first time Matt says that we are doing this sub-regional DevFest in our region. So normally in the past years, we have lots of DevFest just together, to reach out to more developers and then, teach and learn. But this time, given the circumstances, as you can imagine, we are doing this exceptionally for this year to come together with all the chapters, and then it's perfect, like 9 chapters joining all together and doing this DevFest. Amazing. So I would like to thank you actually for joining our community-driven DevFest 2020, which is organized, like I said, by our wonderful GDG organizers. So my name is Kubra Zengin, and then as Matt mentioned, I'm the regional lead for GDG and Women Tech Makers programs at Google. And I've been here for a long time, actually. And thank you, Matt, just telling me that I'm a good friend to all of you. So I really appreciate that one. So maybe I should just a little bit why I'm excited right now. So I can just tell. So DevFest is always a special time, for us of the year that we celebrate our developer communities with great content in many technologies, with great developers joining. So I actually reviewed our agenda for today, and there are lots of great talks coming up. And of course, we have many more DevFests in our region. So if you are interested in any other DevFest for joining, we can share the links with you. So feel free to, just join those DevFests all around to this month as well. So we have more. So once again, I wanted to just welcome all of you and enjoy your DevFest with a great couple of hours of learning. So let me know if you have any questions. I will be sticking around here for the whole day till the end. So you can ping any questions on the chat part, and I'm happy to answer any questions that you might have.
Great. Thank you so much, Kubra. All right. So again, this is a really special event because we have so many different chapters involved. There's actually 10. We're getting an update on that slide. Sorry about that. But I've been involved with the GD program for a long time now, and prior to COVID, we'd see each other a couple times a year at events in person like this. But one of the nice things about COVID, maybe the only nice thing about COVID and the lockdown, is that we are attending more online events. And although we can definitely get tired of always being in front of a screen, it's neat that we can now attend events virtually around the world. And so I recommend checking out, you can see the URL there on the screen, gdg.community.dev, where you can see all sorts of other events that are going on throughout the world. And it's normal now to attend those events because everyone's virtual. And so we have, a lot of chapters here on the West Coast, but we also have chapters throughout the country. And I've made a lot of friends over the years at the in-person events by meeting people from other countries who look differently, speak differently, have a different background. But when we come together and we start talking about technology, it turns out we have so much in common. So I really recommend attending some of these events and meeting new people and learning new things. One second. All right, we're having technical difficulty. There we go. So besides the question form that we're doing today, we also have a raffle that we're doing, and we'll be raffling off prizes throughout the event. Obviously, because the nature of this event is virtual, you won't get your prizes today. We'll be mailing them out. But please visit this URL, bit.ly DevFest raffle. Again, capital R, I believe bit.ly is case sensitive. And we'll be sharing that throughout the event as well. So if we move on too quickly and you don't have time to do it, we'll keep bringing it up, and we'll keep having prizes both during today's live stream as well as afterwards. So you'll have plenty of chances to enter the raffle. Again, DevFest, capital R for raffle, is the form. If someone wants to enter, I'll make sure that it's working by seeing your entry. So I'll leave this up on the screen for just a few seconds. Hopefully someone will enter. The form should be up in public, but it's always nice to get a confirmation. There we go. Thank you, Kevin. I appreciate it. All right. Again, if you have any questions, code of conduct concerns, questions to our speakers, questions about future events, whatever it may be, this form will be up throughout the event as well as afterwards. It's DevFest Q with a capital Q. And let's see if anyone submitted. No questions yet, but that's okay. And then basically at the end of each talk, I'll be reading the questions that you may have for that speaker to that speaker. Hopefully that one's working too. You can also post them in the chat. We'll put them there. The chat obviously is public and it will be recorded. So you keep that in mind as you're posting questions in the chat. So today we're going to start with a special message from some Googlers about DevFest. Actually, and before we do that, can someone just let me know if you are able to hear that audio? Maybe someone who's IMing me could let me know if you could hear the little audio from the recording. No audio is what I'm hearing. All right, hold on one second. We're going to take care of that. That's why I wanted to ask. Make sure that we do this the right way. All right, we're going to do this. Okay. Audio? Yeah, anybody? Yes, okay, great. Then let's get this microphone as close as possible to the speaker, and we'll do it that way.
Hello and welcome to DevFest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for DevFest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local DevFest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes DevFest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Now, 2020 has been a year of radical change for people across the globe. But when difficult times came about, developers within this community came together online to plan a virtual DevFest where each local chapter can participate, helping each other teach and learn when we need to connect the most. And these connections can be so important. I can remember the first developer conferences I went to, where I met people who were already doing the kinds of things I dreamed of doing. They had started companies, built products, and I got to hear the stories of what had worked and what had gone wrong. And we hope that all of you will get to have similar experiences at DevFest this year. At Google, we've always believed that we are only successful when all of our users are successful. While Google and its products may plant a seed, it's developers like yourself who make the seeds grow and thrive. This community of developers has shown us firsthand how you're using technology to help each other during times of need.
Oh. Alrighty. One second.
Let me introduce you to my teammate David to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year, 2010, when I was able to join a large percentage of them. Back then, there were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. While I really do miss being able to join many of you in person this year, I'm happy to be able to continue the celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Over the years, it's been great to see the apps and the solutions the broader community has built with the support of their local GDG chapters. We now have thousands and thousands of developers who are working to address real-world problems in their local communities. Particularly during the challenging times of COVID, I'm impressed by how much your work has made people's lives better. There's a few recent examples that truly stand out to me. Community developers from GDG West Sweden recently worked with the Swedish government to create Hack the Crisis, an event focused on designing, testing, and executing ideas in response to recent challenges. One of the finalists, named Remote and Gigs, helped modernize the Swedish government's employment website to match job seekers with remote work. Nearby in Romania, GDG groups organized a hackathon, gathering 270 different mentors and students from across 8 different countries. The hackathon brought together developers to save lives, to save communities, and to save businesses. Some of the winners included an online platform that connected volunteers with nonprofits across the region, a system to help doctors work with each other and to ease online consultations, and a personal assistant for health and nutrition tracking. Another cool app that they developed was Risk Alert, an app that alerts emergency rooms that a patient with a very rare disease is about to arrive, so that the hospital can prepare for any special needs. In Asia, GDG Tainan initiated the Mask Inventory Map at the start of COVID-19, which crowdsources mask inventory from local store data, combining it with the Google Maps API. The project was so popular that it caught the attention of Taiwan's government, inspiring them to publish public data APIs on mask inventory managed by the government. Taiwan's digital minister has since encouraged the GDG Tainan chapter to create more than 100 different apps to help the local community. In India, GDG Cloud Pune used machine learning with TensorFlow and GCP to help their community with an app that remotely analyzes dental health and helps patients book at-home dental services. They've had over 300 trained images so far, and the developer community is working with local universities to gather more than 50,000 dental images to improve the application. In the Middle East, the region's largest International Women's Day event was held in April in Turkey by multiple GDG groups working together. They had over 2,500 attendees to the event, which included a raffle for online courses and talks in artificial intelligence and data mining. The event helped women across the community and across the region learn and apply their skills. And of course, here in the United States, the GDG Memphis chapter has joined GiveCamp, where software developers in the area donate their skills for nonprofits, as well as helping kids learn to code on the weekends. These are just a small sample of the ways that Google Developer Group chapters and communities like yours all over the world are learning together and giving back what they've learned to really help people's lives everywhere be better. I encourage all of you to continue, be in community with your fellow developers. Think about how can you use the skills and the tech that you're learning this weekend at DevFest, as well as the networks and the communities that you form, the new friends that you make. How do you combine all of these to make a difference in your own area? Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture. But when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako ddagala olaba nti akako okulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obusebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eye, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do. But then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyali n'ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya. Tulina essuubi ne tufuna embeera ennungi okulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for DevFest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app. So to get started with Android, let's see what Chet can teach us.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up CameraX and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we'll use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installing the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our train variables here using the dataset beans that we've just seen. And now we're going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data it didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it. To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real-timey sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting, and I could start using that information to maybe refine my ML-Kit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app. But if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook. This use case focuses on plant diseases, but for other use cases where our ML-based predictions intersect with people or communities, we absolutely need to think about responsible AI themes like privacy and fairness, which you can learn more about at tensorflow.org/resources/responsible-AI.
And don't forget about the web. I've built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers. Now let's take a look. We have our standard project layout with a HTML file, a manifest, and a service worker to make it a PWA. We have some styles to make it look good, and our data folder that contains our TensorFlow configuration and trained model that we're going to use in the app. Now to the heart of the project. Let's go back to the HTML file and see what's happening. We're also loading a webcam object. This is just a class that wraps some boilerplate logic to make it easier to pass camera data from getUserMedia to TensorFlow. And now let's dive into our app logic in index.js. So I'm just going to use Chrome and the debugger here. And this is only so you can kind of see how easy it is to integrate machine learning into your application. So let's get started by clicking the classify button, get the machine learning gears into action, and immediately we break into the TensorFlow tidy function. This is just there to help you kind of clean up any of the memory that TensorFlow uses whilst it makes a prediction. We get our image from the web camera, and then we pass our image back into the machine learning algorithm to make it a prediction. And once we've got a prediction, we access the data, and then we can use that data to update the user interface kind of based on any application logic that we want. And that's pretty much it.
Great. So now you have the platform for building a real app. With the tooling from Android Studio, the APIs from CameraX, Jetpack, ML-Kit, Colab, TensorFlow, Firebase, Chrome, and Google Cloud, you have a lot of things that just work better together. This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too, so developers can suggest improvements, optimizations, and even additional features by filing an issue or sending a pull request. It's a great way to get your hard work in front of even more people. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject. Indeed, we've already open sourced the bean disease sample we discussed in this video, so you can have a great place to start.
Thanks, Pooja. And as you mentioned, open sourcing a project is a great way to make it grow and inspire people to adopt and extend it. If you want to learn more about what you've seen in this video, please visit us at developers.google.com.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And when we make difference the new normal, we will usher in new opportunities to grow our business by earning the love of all of our users. So whether you're 1 or 105 years old, live in a city or a remote village, on Wi-Fi or cellular service, Google is there for you to make sure you have the answers you need when you need them. Product inclusion is exactly what it sounds like, bringing an inclusive lens throughout the entire product design process to create more inclusive products for our users. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com. Thanks.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. So, what can you expect next from your local DevFest? We'll have technical talks, breakout sessions, networking opportunities, and more. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter, with speakers from Google, women tech makers, Google developer experts, and your local community. Be sure to claim your badge for participating in DevFest 2020 by going to google.dev/DevFest2020. You can earn even more badges by mastering different Google technologies available on developers.google.com/learn. As a reminder, one of the most important parts of DevFest is providing an inclusive and harassment-free experience for everyone. As an active participant of DevFest, today, we can all agree to treat everyone with respect and to speak up if we see or experience harassment of any kind. Together, we can create an environment that is welcoming and inclusive to everyone with us here today. Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest. And lastly, don't forget community is all about getting to know one another. Use the virtual breakout rooms and chat feature to connect with other developers near you with shared interests. We hope you enjoyed DevFest 2020.
All right, thank you so much. And just a reminder, we do have a question form that I'll pull up. One second. There we go. As well as a raffle. We've gotten some entries already, but please go ahead and enter the raffle if you haven't done so. 1 entry per person, but we will be raffling off some items now, and then some more items throughout the event as well as afterwards. So please enter. If you don't enter now, that's okay. You'll still have time later. For privacy reasons, we can't show everyone's name on the wheel, but we'll say who wins with a publicly shareable version of their name. So 1 second while we get that going. You still have time to enter. Also, if you have questions, please submit the questions. It's bit.ly DevFest with a capital Q. Let me go ahead and share that screen so you can see it. There we go. So here again for the questions. And just in case for the raffle, here we go. One other thing I wanted to point out, again, today's event, one second, see if I can find the right slide. Sorry about that. That's not the right one. There we go. This event is brought by the most number of chapters on the West Coast that we've ever done before, all together. So very exciting. Okay, looks like we got some more entries in the raffle. There we go. Oh, all right. All right, so we're going to do a random number. One moment. All right, and the winner of our first prize is Santino. Santino, congratulations. Just as an FYI, if there happen to be two people who submitted their publicly shareable name that are the same, I apologize, but this is the Santino that I will be emailing, letting them know that they won our first prize, which includes a bunch of DevFest swag. Okay. All right. Again, there'll be time to enter the raffle. And then as we start our next talk, if you have any questions, feel free to use the chat, or if you'd like to privately ask a question, you can also do so at our bit.ly link, bit.ly/DevFest Q. And I'll be checking it throughout the talk. Just a reminder also, this event is being recorded and live streamed. So keep that in mind as you type in the chat. It'll be there forever. All right. So our first talk today is by Iñaki Villar. He's a build engineer at Tinder. And he'll be speaking today about building Android projects with KTS. Iñaki, can you hear me and say hi?
Hello, perfect. So
great. Nice shirt, by the way. I have the same one. I really like it.
I love your layout. So with the microphone, with the headphones, I mean, whoa, that's perfect. So, I mean, I'm with a laptop and that's it. So hope that everything is okay.
I've got a lot of equipment in front of me. So if you need anything, you let me know.
Okay, perfect. So let's share the screen.
And so if you use the screen share button at the bottom, you can then choose to share a tab. As I learned today, if you share a tab, you can choose to share the audio also.
Okay, so let's see that keynote. Okay, so it's okay?
No, so we're seeing you still.
Okay, so let me look at one monitor only. Can I use one monitor only?
Yeah, you can use one monitor. So choose at the bottom of the screen, there's a share screen button. You choose that, and then you can choose either to share an entire screen application window or Chrome tab.
Okay.
And when you do that, it should pop up in the studio, and I'll be able to select it.
Share screen. Okay. Okay.
And just as a reminder for everyone at home, we are using StreamYard today. No affiliation, but it is a great service that I like a lot. One of the things I like about it is that it works with a Chromebook. I use a Pixelbook, and so it's nice not having to install software to be able to stream. So it looks like we're having a little technical difficulty right now. Go ahead and pull that up, the little banner there. Some other things to keep in mind while we're here. If you're interested in other events, you can find more events at gdg.community.dev. We have this event, but also many others. All right, and here we go. And Iñaki, take it away.
It's okay?
Yep.
Okay, perfect. So you're seeing the presentation, right? Not the speaker notes.
We actually see both. Yeah, you know, we're seeing the speaker notes. You're right. There we go. Perfect. Thank you.
Sorry. So sorry. Okay. Hi, everybody. Thank you very much for having me. My name is Iñaki Villar. I'm from Spain originally. I moved to LA last year, so perfect times to come to the States, right? And yeah, so I was not preparing anything for as introduction, but I saw the videos, the presentations before, the YouTube videos, and yeah, I have to say that I love the DevFest, right? So I have been speaking in a lot of conferences around the world, right? But always I feel more comfortable in the DevFest, right? Because for me, it's like the foundation, right? So it's like the direct contact that you have with the local community always. And that's something cool, because sometimes in big conferences, we have like big companies, right? It's very expensive, right? And sometimes it's more corporative, right? But the DevFest or the GDG always is more local, and that's the main reason, right? So that's the very important in terms of the responsibility with the local community. Okay, saying that, so I'm working as build engineer in Tinder, so I'm very happy to be here. So this talk is going to be building Android projects with KTS. It's going to be a little bit technical and maybe requires you the knowledge of the Android applications. So what's this of KTS? KTS, it's just an extension that we are adding to our build Gradle files, right? So if you're working with Android, you know that the build system that we are using is Gradle, right? So the recommended one, right? So Gradle, you can define the build scripts with Groovy. Actually, you are using Groovy to define the build scripts. And KTS is just the extension to indicate that we are going to work with Kotlin to model the build scripts, right? So, and this is like the first thing that we have to learn is that KTS is not coming from Kotlin, it's coming from Gradle, right? So that's something that it's going to be, we are going to see later in deeper. So, how is like defining a build script, right? So when you're using Android, so you know that, well, you have like to compile the code, you need to apply the dexing or D8 to transform the bytecode generated by Java or Kotlin compiler to the virtual machine, to the Tautic virtual machine compatible, and all these things are happening with the Android Gradle plugin, right? So, and the Android Gradle plugin is going to, for example, to orchestrate everything to generate the desired output. That in our case is an APK, right? But we need to define the build, right? So, and defining the build in case of Gradle is doing this example with Groovy. So other languages, like for example C, well, you have like CMake, or previously in Android we have Maven, and so the build system are the ones that is going to help us to build the things. But what about the build definitions, the build configuration? So other languages like Anne, I remember, or Maven, you were using XML, right? But in Gradle is using Groovy. And how it looks, it's quite simple, right? If you are aware, so you define, it's very declarative. So you declare like the plugins, and then you have like some configurations that they are given by specific plugins. Gradle is super flexible, is super extensible, and that means that you can extend. Actually, the Android Gradle plugin is offering you this plugin that is Android application. That this is going to help you to have the configurations like the build types, like the flavors, like specific implementation details from the Android Gradle plugin. So how it looks in KTS? Well, it's almost the same, right? So as you can see, and that's something that we have to keep in mind, and it's very important. So the KTS is just to write or build scripts in Kotlin, right? So we are not going to change how works the build system. So the base of the build system is already there. So here, we can see step by step some of the differences, right? So one of the first differences we can see when we apply the plugins is that we can start seeing some of the nice Kotlin features that we are using, right? So for example, here we are using named parameters. That's something that we were very excited at the beginning when we were migrating to Kotlin, right? So it's more declarative. I know this parameter, I can give to the reader of the code a context about that. Then if we go to the next step, we can see that it's almost similar, the Android configuration, the Android specific configuration. We have some caveats, right? So how we are defining the compiler SDK version, or if we are using operators to assign values to the properties, like in the version code or in the version name, but it's almost the same. And here, yeah, so the build types in this case is a little bit slightly different and maybe tricky. That's is how we are retrieving the build types, right? So you know the Android Gradle plugin is having this concept of build types, and these build types can be configured. For example, here we want to shrink the code with we want to shrink the code with R8. So here is more tricky, right? Because we are using some specific configuration from KTS to get directly the parameters. So that's the thing. Almost Groovy and KTS, it looks the same, right? We have some tricky things, but it should be the same. So that's important to understand that, well, KTS at the end, it's not going to be, if we use the same configuration, for example, our applications much faster. But we're going to explore and to understand better how we can do this thing and how we can change, right? So how we can change our base code in that. Additionally, because we are using KTS and the code is compiled, that's one of the benefits, right? Because Groovy is like dynamic and Kotlin is a statically typed language, right? So that means that the IDE, when we load the KTS file, we can see the highlighted code and we can, it's okay? Yeah. We can see the highlighted code. And this is going to help us to understand better how we are building the project. So if you remember, when we migrate, or when Kotlin was released as official language for Android, I think that one of the things that a lot of people say that, no, I don't want to know anything about Java, whatever. But I think that for us, it was quite important because it helped us to understand better the platform. So before with Java, so we were only, well, it was like a language to be driven and we wanted to develop the features and that's it, right? When Kotlin started to roll out in the Android world, we start to be more interested, for example, in some concepts like nullability. For example, like the bytecode generator, if you were working with code coverage, you check that the output was different because the Kotlin compiler was generating the bytecode, and so on, right? The same happened with the KTS. So KTS is going to give you the knowledge, or you are going to understand better the builds, right? The build system, because even that we are very familiar with Gradle, so we know a lot of Gradle, so we need to understand better how work the build system. And highlighting the code is like a simple thing, but it's going to give us a better context of our build scripts, right? Here, for example, as you can see, the Android configuration, we have like this highlighted code from the Android Studio that is saying that the Android configuration represents a base app module extension. This class is, it comes from the Android Gradle plugin, and the same for the build type. So that's something that is quite cool. With Ruby, we don't have this reference, and this is going to help us, if you have interest, of course, to trying to understand and to learn more about KTS. The same, you can navigate. So again, it's a Kotlin file, it's a Kotlin script, it's a Kotlin file. You can navigate. Oh, that's cool, right? So for example, we can go to the -k version, we can see the signature, and we can see from where it's coming, right? Again, we are talking about Android. There is nothing to do with Gradle. It's coming from the Android Build Gradle plugin. And something that is quite cool is the autocomplete, right? So that's something that, again, and that's absolutely, I think that it's true, right? So we don't like, usually we don't like Ruby, right? Because, maybe we were coming from Java and Kotlin, right? And you are more flexible in Kotlin, right? So you have spent the last years working with Kotlin. You are more efficient. You have more knowledge, and it's going to be much better, more natural. This doesn't mean that Ruby was bad. No, absolutely. Ruby is a very good language to define the build, but the truth is like we feel more comfortable with Kotlin, and that's the truth. So because we have this autocomplete, when we are defining, or for example, in that case, we want to define the release build type, we can ask the IDE to show us the autocomplete values, right? So, and that's something very cool, because again, we have the awareness about what are the properties or methods that we can use in a release build type, for example. So it's quite cool, actually. So what we have to do to work with KTS, right? So actually, you don't have to do anything, right? So the only thing that we need to extend or build Gradle configuration files with KTS, as you can see here. So, but how it works internally, or what is the deal? Because KTS is not something new. So I remember to work in a project maybe 2-3 years ago, and we were working with KTS. So it's absolutely not something new, but maybe now in Android is becoming more massive. So KTS is working on top of the Gradle Java API. So that means when you try to create build Gradle KTS file, you have access to the default Gradle Java API. Like what? Imagine that the project is a basic concept in Gradle. So internally in the domain scope of Gradle, every subproject or every module is a object project, right? So we have this access to the KTS. Right? Not only the project, to the default Java API, Ruby API. Additionally, we are using a Kotlin DSL API. Again, we love Kotlin, and we know that Kotlin is quite good trying to define domain-specific languages, lambdas with receivers, extension functions, delegations. So the language helps you to create like these DSLs. So we have this Kotlin DSL API in top of the KTS. So for example, if I want to use in my dependencies an implementation configuration, I mean, if you know in Gradle, if you want to load, I don't know, some dependency, for example, here, I'm going to use implementations. If I'm using KTS, I can click in the implementation and I can see that the definition actually is extension function. This is given by the Kotlin DSL API. So the Kotlin DSL API is going to provide you somehow different interfaces that they're going to simulate that you are working with Ruby 2, right? So because at the end, the implementation is going to the internal implementation details of the dependency handler of the Ruby, of Gradle, sorry, of Gradle. And that's why. So important to think and to step like KTS is working with Gradle and is working with the Kotlin DSL API. And yeah, so that's something that we need to think. So we are working with Kotlin DSL inside Gradle. Well, Gradle provides this Kotlin DSL. So what's the deal? Are we using a different version of Kotlin? Are we using, how it works? Well, actually, it's quite interesting because Kotlin is working inside Gradle. So Gradle includes a Kotlin compiler embedded. So that means that even that you have your own dependencies of Kotlin, so internally, each version of Gradle is released with an own Kotlin compiler embedded. That's something important because this Kotlin compiler is going to add you like two dependencies, like Kotlin Reflect and Kotlin Standard Library. So here's the thing right now. Actually, we are in the transition between 1.3 Kotlin and 1.4 version, right? So and some people, they have started to complain about the build scripts that they were using with KTS. They were not compatible with Gradle, with Kotlin 1.4. And that's the reason because, well, you are using a Kotlin compiler embedded inside Gradle. And what's the version? So at the end of the day, today, well, today we have officially 6.7 in Gradle. So it's using a Kotlin compiler 1.3. I think that this is expected to use the in Gradle 6.8, the version 1.4. I'm not sure, but I think that is expected, right? And what's the implications of this? I think that 99% of the cases, it doesn't have any implications for you. But if in your build script, you are using some cool features, for example, for Kotlin 1.4, think that is not going to be available because the Kotlin compiler, it works with 1.3. Again, it has to be very specific versions. I remember, it was like, 2-3 years ago, or well, I don't remember the exact date, but when we were migrating from Kotlin 1.2 to Kotlin 1.3, I had the same problem, but with coroutines. If you remember, in 1.2, coroutines was like in the experimental namespace, right? And it was like a real problem because you were using maybe a Gradle build script with Gradle and a Kotlin compiler embedded with experimental coroutines, and then in your official Kotlin Gradle plugin, you were using the coroutines that were not experimental. So again, keep an eye on this if you are using very specific Kotlin features for your build scripts. Okay, so let's move on and let's see one example. So we have a model where we are working with, we have like our build Gradle KTS. Okay, so we have like this typical dependencies block where we are defining the different implementations that we want. Again, so after 2-3 years, we are Kotlin developers. We are very good Kotlin developers. We optimize, we love the language. And the first thing that we are going to do or think is, well, I want to centralize the versions, the dependency versions, right? Because it's not efficient every time that I'm changing something to change the multiple files. So the first thing that I'm going to do is like, it's a simple case. I'm going to create object dependencies, right? And that means that later in my build script, I can define these dependencies on a better way. This is beautiful. And additionally, I have the opportunity to have the autocomplete. That means that when I'm trying to create a new dependency, I'm going to have like this thing. This is perfect and this is nice. But let's move to the next model, the model B. The model B, we have another dependency, so we have the same dependencies, but when we want to use the same technique, or we want to replace the dependency with the object defined at the scope that we have defined in the previous model, we cannot access to these dependencies. And we have to think why we don't have from the build script in theory is compiled to the next model B that is compiled. And this is a perfect case because it's perfect to understand how works the KTS. And I think that this is a little bit misunderstood of how works KTS, and we are doing the same mistakes. I think that I did this mistake, and we need to understand how it works internally in these things. So if we extract the concept of the build stack in terms of APIs or how we can configure our build scripts, you have to think that in the class path, for example. So you need a class path to build the Android project, right? In the class path, you are going to include the Android Gradle plugin, for example. If you are using a pure Kotlin application in Gradle, you need to include in the class path the Kotlin Gradle plugin. Okay, so but this class path is nothing to do with the class path that you are going to use in runtime and in compile time. For example, if you are using, for example, retrofit, so the dependency of retrofit is in the class path of your application, not in the class path of your build script, right? And let's check this class path. So the first term is the build source. The build source is something that is a convention from Gradle. And there, usually, when we are defining our build scripts, it's a perfect place to put the common logic, encapsulate the build logic. At the end of the day, build scripts are logic, right? So, and we can try to optimize encapsulating everything in the build source. For example, so here in this build source, I'm defining some extensions and some plugins, right? These, by convention, again, are going to be included in the class path. That means that this, I don't know, unit test extension is going to be available in all the build scripts along the project, across the project. This is by default. You don't have to do anything. You can create your build source, and you are going to have this functionality by default. So what about this build Gradle? That's something important to know, right? And to see the difference. In a typical build Gradle file like this one, I'm going to define a dependencies. These dependencies are going to be included in the class path. For example, if I'm defining something from the Android Gradle plugin, I have to include here the Android Gradle plugin as implementation and will be accessible in the build scripts. But if I define an object dependencies in this build Gradle file, it's not going to be available. And again, so think about the dependencies that you are including in a build Gradle file in the build source are going to be available for all the project. And of course, you can use Kotlin DSL to extend this functionality. For example, plugins in Gradle has been there since, I don't know, since years, since the beginning, right? But as well with the KTS at the Kotlin DSL, so you can create your own plugins accessing this DSL API. For example, imagine that I'm creating a simple plugin, right? And in this plugin, I want to define the repositories and the dependencies, right? So look that I'm using this Kotlin DSL namespace dependencies and repositories. That means that the Kotlin DSL are going to give me the possibility to define in a more declarative way in the plugin which repositories I'm going to use in the application or which dependencies. So KTS can be used in the build scripts, and Kotlin DSL, you know that is below of the Kotlin of the KTS, it can be helpful to define plugins that you are going to be used later. So something here to understand that now in these times that we are living, so maybe you have to give some compatibility to Ruby and some compatibility to KTS. So depending on the functionality, keep in mind that maybe you have to duplicate the definition. So, okay. Then on this stack where we have the Gradle API, the build source, we have then the plugins and the build scripts blocks, right? Okay, we have passed the first step, that's the build source, but then we have the build script block, the build scripts blocks. Well, the name is quite clear, right? Build scripts. So usually in your main build Gradle, you are going to see the build script. That means that the dependencies included in this block are going to be available if you are defining from the main build Gradle across all the configuration files that you have in your project. So these dependencies are going to give you the opportunity to define different plugins, right? So for example, you define like the Android Gradle plugin, and then you define the plugin ID. So if you have, or if you want to extend the Kotlin Gradle plugin, you can define the Kotlin Gradle plugin in the build source, or you can define the Kotlin Gradle plugin in the build script. And finally, we have like the steps of the build Gradle configuration files and the build Gradle. So I don't know, but maybe it's a question, but if you define a build script in your build Gradle KTS, the scope of the class path is going to be the own file, right? If we change the perspective of how we are seeing this build stack, we can see that first of all we have the Gradle, then we have the convention of build source, then we have the build script plugins, and finally we have the module A, build Gradle KTS, module B, build Gradle KTS. And that's the reason, because I cannot access to the object dependencies defined in the module A, right? So the next question is, well, if this is not the case, or what should be the correct way to centralize the versions or the multiple versions that we are using in a project? Yeah, so our first thought, and my first thought, was always the build source, because we say that build source is for encapsulate the common logic that we are using in the project. But this has a problem, and it's the cache invalidation. So the build source is is like the best case to centralize the common logic of the build, but not the version. So at the end of the day, the versions that we are using, for example, in our Android projects, if you are talking about a high modularized project, maybe you're going to have like, I don't know, 30 developers updating this file. Every time that you update something in the build source, KTS is going to invalidate the cache. And this is something that is going to have like an overhead in your builds, right? So remember that if you are working in a small project, if you are working in, or you want to show the power of KTS, it's okay, right? But it's a bad practice to put this. I think that maybe versions like 6.8 of Gradle 2, they are going to improve the incremental compilation for KTS in the build sources files. But well, until today, and I have seen, well, for myself, these things, and it's very bad experience, right? So what's the solution? Well, we have different kind of solutions if we are interested in centralize the dependencies in our project. First is the Java Platform plugin. It's a plugin coming from Gradle. And well, actually, maybe it's a little bit out of the scope of Android, right? It's more about the Java world. But again, so this specific problem of centralizing the dependencies, it should be solved by the build system approach, not by your knowledge of the Kotlin language, right? So, and knowing the build system approach, we know that this Java Platform plugin allows us to define like different dependencies in case of modules. For example, this is like the use case that shows in the website of Gradle, right? We have like dependencies in one module where we are defining these two HTTP client and commons line. So the consumer actually are going to consume like this platform, this platform configuration with the dependencies, and the implementation details of the versions relies on the version itself, of the first module itself. So again, imagine that you have like the typical dependencies where you are working with networking, dependency injection, and so on, right? So now maybe, so it's the moment to think that it's better to create like these Java Platform plugins, modules, right, for this kind of dependencies and to have separated the things. And again, so I think that understanding how works the build system is going to give you like a better perspective and how to solve these problems. You have the website here. I think that I wanted to explore a little bit more. I have seen another repositories like JUnit 5. They are using this approach. And I have to mention, of course, this plugin, this repository that is called Refresh Versions. That, well, it's doing a lot of things, right, more, but if you see the internal implementation, they are using this Java platform approach to solve these central dependencies things. So again, sorry to repeat, but try to solve this problem from the build system approach, not from the language approach. Okay, so we are arriving to Android Gradle plugin for one. So you know that this week, right? So it was the release of Android Studio for one. And every release of Android Studio, it comes with the Android Gradle plugin. So the Android Gradle plugin for one is very exciting. So first of all, it has a full support of Kotlin DSL. So what's different, right? So I told you that I was working like maybe 2-3 years in a big project, even with KTS, right? So the thing is that Google or the Android team or the Android tool team was saying that it was not 100% compatible, right? So with the Android Gradle plugin. So of course it's up to you if you want to use KTS. So there was no problem, right? But now we have like the message from Google saying that it's full support of Kotlin DSL, and that's something that is very nice. Later we have the API and DSL are being rewritten in Kotlin. So if you go to the documentation of Gradle, of the Android Gradle plugin in the Android site, so you have like everything has been now, as you can see in the code, you can infer that we are talking about interface Kotlin, and that's something very cool. For example, if you have you want to define the application ID in your Groovy version, in your project with the Android Gradle plugin 4, and you navigate through the code, you can see that the application ID, in that case, well, it's a Java class, right? So we are using a product flavor. This is an implementation detail of the Android Gradle plugin. But in the new version, in Android Gradle plugin 4.1, we have this interface, or well, in that case, this property in Kotlin, and everything is in Kotlin now, and that's quite cool. So keep an eye, because maybe could be that some cases I was reading this morning or yesterday, that if you are using version codes or version numbers in libraries, maybe can lead some problem. And yeah, so you have to test it. So I think that the only problems that you can have is if you were using before KTS. That means that some interfaces that you were using in your Kotlin scripts pointing to Android Gradle plugin 4.0 were in Groovy, and now they are in Kotlin, and you can have some incompatibilities. So keep an eye, because it's from this week, and it's something that we need to explore. But actually, I'm very excited about this. So actually, okay. So a little bit to sum up a little bit the things. So first of all, I want to emphasize that KTS is Kotlin in Gradle. It's not Kotlin with Gradle, right? So the implementation of the KTS is given by the runtime is driven by the Kotlin compiler embedded in Gradle. So that's something that maybe you can create like a ticket for JetBrains, and they're going to say, well, but this is like a problem from Gradle, right? So it's something that you have to be clear about this. Build system internals, yeah. So it's quite important to understand that even now with KTS, and again, so in the past, I have seen like maybe more problems of performance using KTS, right? So, and this led to understand better this actually architecture, well, not architecture, but how it works internally the Gradle build system, right? So again, keeping in mind that, for example, the build source is by convention something that you can put all your common logic there. It's quite important, and as well, trying to understand that you create some objects or some classes in your build Gradle files, they are not going to be in the scope of the different build Gradle files. Again, so promote trying to optimize, or to optimize to trying to work on the build logic more than in KTS. So what means this? We are very excited with KTS. Google has said that now we have full support with Android Gradle plugin for one, and the first thing that we are going to do is replace everything with KTS. No, that's wrong, right? So we need to understand better, or we need to deal with our build logic as code. One thing that I didn't mention is the build source. For example, when it's executed, you can add tests. So your build logic can be tested, and your build logic can use even their code features in Gradle, like the Gradle test kit, where you can define like end-to-end tests with your plugins. So try to deal with your build logic as code. Try to define, to encapsulate, to model the build logic, and then the KTS implementation. The KTS is only a detail of implementation. As I show in the second, third slide, the comparison. To compare KTS with Ruby, we can see that apparently it's the same. And honestly, in my opinion, the perfect build script should be a short build script, right? A few lines should be enough. If you see a build script with 20, 30 lines, so defining the Android configurations, whatever, it's not correct. So again, encourage the build logic plus the KTS. And yeah, and finally, yeah, so we have the green light from Google, 100%, so it's totally supporting. It has been rewritten in KTS, in Kotlin, all the interfaces. Check the Android Gradle plugin, because you can get some benefits of that. Well, in terms of resources, I would like to include some different, again, so KTS is not new. If you look in, if you search in internet about different different resources. You have like multiples of articles about that. But recently I want to mention this. Okay, the Android Gradle plugin for one, this is not something from this week. This article is from a couple months ago, where the Google engineers, they were explaining this change of the KTS and how they have driven to this change too. It's quite interesting with some examples. And of course, the new API that is included in the Android Gradle plugin for one, like the onVariant or onVariant API. Okay, the next link that I want to share is the migration, right? So Gradle adds some migration logic because, well, migration references, resources, because at the end of the day, so I mean, if you are totally new, for example, in Kotlin, or you don't understand the build system, it can be a little bit tricky, right? There are parts, for example, when if you are using a non-explicit plugin, imagine that, for example, I'm using the Android Gradle plugin, right? So if I'm include the Android Gradle plugin and not in the main build source or in the main build Gradle, so maybe I have to do some tricks, like, for example, configure the Android extension. So there are some tricks that, or some gotchas that you maybe need to learn, but they're like very basic. So in terms of immigration, of course, another resource coming from Gradle is like a complete set of different Kotlin DSL samples. These samples comes from Maven configurations, multi-modular applications, Jacopo configuration, and it's great. It's perfect. So take a look on that. And yeah, finally, well, Android text, that's something cool, because remember that I was saying that KTS is okay, but it's more cool if you encapsulate your build logic. The official repository of Android text is the best example to see. So actually, it's quite strange. They are working with Groovy, right, in the build script files, but the configuration, or well, the build source folder contains all the plugins that they are using internally in terms of, for example, the Android Text UI plugin. And it's quite interesting to see how they are modeling the build logic, and at the end, how they can test the build logic. Finally, the build scripts of the Android Text should be very short, and I think it's a very good use case. And finally, I want to share this very cool repository. The last time I saw it, it was with a snapshot version or nightly version from Gradle versions. And it's a way to define a project with an idiomatic approach from the build perspective. So if you are maybe a little bit new in this, it's going to be very abstract and complex. But I think that it's a very good use case to see how you can go to the next level in the Gradle configuration, right? Actually, there was like a typical problem with the Jacopo configuration, where, you know, so what Jacopo in a simple project is okay, you can generate the coverage, but if you are working in a multi-modular project, you want maybe to aggregate the reports, and with Ruby was okay, with KTS was not okay, and well, they are using here. I saw one perfect example how to do the aggregation of the Jacopo. This is only just one comment, right? But don't well, try to check this repository. And yeah, so I think that I'm done in that case. So again, KTS is there, it's ready. Now this week we have like the green light for Android. I want to thank you again, to thank Matt for everything. I'm very excited. And then if you want to interact with me, whatever, so this is my Twitter account. And yeah, I'm ready for questions. Thank you very much.
Thanks. That was wonderful. We do have some questions. Let's switch to a different. There we go. That's a much better layout. All right. So the first question that we have for you: are your slides available to be shared?
Yeah. Well, in 20 minutes, maybe. Yeah.
Okay, perfect. Thanks so much. We'll try to get them uploaded to the YouTube video as well. Okay, now these are more technical questions, so bear with me. Hopefully I'll read them correctly as well. Is there a minimum version for the Gradle distribution and or the AGP to use the Gradle Kotlin DSL?
Okay, well, we saw that 6.6, Gradle 6.6, that's the basic reference, even that 6.7 was released this week. It's working with 1.3. Okay, so 6.8 maybe it's going to work with 1.4, and yeah, you remember that, for example, the first one, it was Gradle 4.3 or something like this. So actually you have the full compatibility with Gradle and KTS. I think that you can work with even Gradle 5 with Kotlin 1.3. So yeah.
Okay. Great. Just a reminder also, if you do have questions, there's the URL on the screen. It's bit.ly/devfestq with a capital Q. All right, next question. I've used a few different IDEs to work with Kotlin. Which do you prefer and why?
Well, IntelliJ, if you are not working with the UI part of Android, right? So if you are not going to get the benefit of the Android Studio, so IntelliJ works quite well. So I mean, if you are in a pure JVM project, or if you are in an Android project where you don't have to do anything with UI, IntelliJ for me is the best option. If you have to do something with Android in terms of the database inspector, or you want the goodies that is included, of course, Android Studio, and Android Studio is even better every time.
Okay, great. Next question. Okay, bear with me. Are there any issues with implementing third-party libraries like Jacoco and SonarQube?
Well, Jacoco, I think that Jacoco is is considered a base plugin from Gradle. So you don't have to do anything. You can use only Jacoco, and that's it. Only specify the version for the instrumentation issues. And then SonarQube, no. I don't think that maybe in the past could be any. I remember some problems with SonarQube, but actually it's quite cool. So I think that not now.
Okay, great. A couple more. I'm new to mobile development. Would you recommend that I focus on a single platform, learn both Android and iOS, or learn Flutter?
Yeah, so well, I would recommend to learn only Kotlin. No, but so at the end of the day, Kotlin is going to give you the versatility to understand if you don't know anything about language. Kotlin is very good starting point, because if you want to go deeper in JVM languages, Kotlin is like perfect, because you're going to understand better Java. And if you are so brave, Scala in the future, then if you want to do web, or you want to do like more multi-platform with Kotlin, so it's possible, right? So I would focus on Kotlin. Now Flutter, honestly, I don't have any inputs about Flutter, but it's around, right? So everybody talks about Flutter.
Okay, great. That's good advice. Another question. Actually, this is the last one, I think. I've heard complaints that the build source directory can be frustrating to work with because of Gradle project sync. Have you experienced this?
Absolutely. So when I was explaining about the build source, the build source is on the top of the, let's say, of the class path, right? And if you change something there, you're going to invalidate everything. And if you invalidate everything, that means that your task, they are not going to enjoy the incremental compilation, right? So, and every time is much better. Actually, I think that in the 6.8, the incremental compilation for the KTS in the build source is going to be improved. But in the past, yeah, we have a lot of problems, even in the company. So we tried to do something in the build source, right? So some plugin, and we move it to an external dependency, right? So that's very conservative approach. But again, think about how often it's going to be updated, the build source folder. If it's going to be updated a lot of times with your code, so you're invalidating the cache. And if you have a lot of teams, a lot of members in your team, is going to be like overhead. But again, it's improving every day.
Okay, awesome. And it looks like those are all of our questions. So thank you so much for joining us. Excellent talk. And then, as I mentioned, we'll be uploading your slides later today, we'll say. And if there's any other further questions that come in, I'll also forward them to you so that we can get back to our viewers at home.
Thank you very much. Thank you very much, Matt, everything, and enjoy the DevFest.
Thanks.
Bye-bye.
Bye. All right, everyone. Let's go ahead and bring back our slides. Again, that was Iñaki Villar, a build engineer at Tinder, talking about building Android projects with KTS. And feel free to continue submitting questions. We'll forward them on and then respond on a public channel. This video will be also available to watch later. In the meantime, please enter our raffle at bit.ly/DevFest raffle with a capital R. And we'll be doing another auction very soon. Also, be sure to mention us on social media with hashtag DevFest. We'll go ahead and wait for some more raffle entries. Looks like we just got a couple. And just as a reminder, the raffle is not going to show the names of people, so feel free to enter. There's the publicly shareable name that I'll say just so that we know who won. And I've actually brought up the wheel this time. We'll be doing the next raffle with the wheel, but the wheel will only contain numbers, and then I'll cross-reference the sheet. So protect everyone's privacy. Another thank you to all of our GDG chapters who have made this event possible. These are our chapters throughout the Pacific region, which spans all the way west to Hawaii, and then the 3 coastal states of California, Oregon, and Washington. There are actually many more chapters available too. So if this isn't, if you don't see a name that's near you, you can learn more about the GDG program and other chapters that might be near you by going to gdg.community.dev. Got a couple more entries for the raffle. Keep it open just a minute more, and then we'll do our next raffle drawing. Oh, they're coming in quickly. We'll see. Another reminder, this event is being recorded and live streamed. You're probably watching it from the URL, but if somehow you're watching it a different way, you will be able to come view it again later, which also means to please keep our comments clean and follow our code of conduct, because it's being recorded, and especially while our speakers are speaking, it'd be really hard to somehow blur out a comment if it was inappropriate in the video. Alrighty, so let's go ahead and see if I can pull up our video, our wheel, and we'll do another raffle drawing. 1 second. Okay, here we go. Got it working. So once again, we're using numbers. Those numbers correspond to names in the sheet. And that way we protect everyone's privacy. For those of you with a detailed eye, you may notice the number 11 is winning. That's our first winner, Santino, who won our first prize earlier in the event. So that's why Santino's number is no longer there. We didn't, skip a number. And then as more people win prizes, we'll take them out to ensure that everyone gets an equal chance of winning the prizes throughout the day. Alrighty, so let's go ahead. This wheel was brought to us by Martin Omander, who graciously built this amazing tool, available at wheelofnames.com. It's free to use. You can customize it, change the colors, change the logo, all sorts of stuff. It also works with a Google Sheet. A lot of cool features in there. Let's tap to spin. All right, that was a close one. I wasn't sure where that was going to land. It looks like Rich C from LA is our second prize winner. The winner of our second prize, I should say. And I will take that number out of the list. All right, congratulations. Let's do another drawing for another prize. Again, we have a lot of gift packs that contain various GDG swag and Google swag that we're giving away today. If you'd like to enter, feel free if you haven't done so already. The URL is, sorry, I didn't have it ready. There we go. bit.ly/devfest raffle. And let's go ahead and do another drawing. Oh, it's a low number. All right. Third winner. The third winner is A. Frank. That's A. Frank. Congratulations. So for all of our winners, what we'll be doing is sending out an email right after the event, letting you know that you won, and then asking for a shipping address so that we can send you your prizes. Again, you can enter the raffle at bit.ly/devfest raffle. And if you have any questions about the event, we had some that have been coming in about the YouTube agenda and things like that. We'll be trying to respond to those in real time. There's a question about Slack or a Disrupt channel for the event. We don't have a Slack for the event, but many of our chapters have Slack communities, Slack channels. And so those can be joined. The best way to learn about them is to visit gdg.community.dev and join your local community. That way you can then become a part of that community and join their Slack. Also, just a reminder, hashtag to use today if you're sharing anything is DevFest is trending. I'm sorry, just hashtag DevFest. And then if you want to also include an app mention to your local GDG chapter, that would be great. I'll go ahead and pull up some of the chapters that are participating today. 1 second. Here we go. There we go. And so when you go to gdg.community.dev, you'll be able to find the GDG chapters closest to you. They're all over the world, and you can join as many of them as you want. We all hold events at different schedules. So the more you join, the more likely you'll find events that fit your timing, your schedule, as well as on the topics that most interest you. So go ahead, check out that site. It's a fairly new site, great, easy to use, has single sign-on, and a lot of new functionality coming on the way as well. So our next talk will be starting in about 15 minutes. In the meantime, if you want to grab some coffee or a snack, we'll be back then. We'll do another drawing right before that talk, so you might want to come back a little before noon so that we can do that drawing and see who our fourth winner will be. All righty. We're coming back now. Hopefully you were able to grab a snack or a drink and take care of anything you need to take care of. Thanks again for joining us on a Friday during the day. But one of the beauty about COVID and the situation we're in is that time is somewhat nebulous now. You can work anytime, anywhere, and join a DevFest anytime, anywhere also. Before we bring in our next talk, we're going to just kind of review code of conduct and do another raffle. Also, chance to enter any questions that you may have. Just another review here, our code of conduct. Let's go back a couple slides. Sorry about that. Here we go. All right. I guess we can remind you who I am too. My name is Matt. I'm a community organizer here and moderator for today. If you're just joining us, just a reminder again, the code of conduct, be excellent to each other. The comments are being recorded, so keep them clean. We have a zero tolerance policy. And if you see anything that doesn't make you feel comfortable, let us know. You'll be able to submit anonymously to us on our question form if you choose. Both questions about the event, questions to one of our speakers, or anything else. Keep it positive. And again, zero tolerance policy. So please, please, please keep the comments clean. Greatly appreciate it. All right. So we're going to bring in our next speaker. One second while I pull that up. Oh, we're going to do another raffle. I forgot. Okay, let's do that raffle. I'm going to go ahead and share the wheel. Again, if you want to enter the raffle, if you haven't done so yet, you can do so at this bit.ly link. It's bit.ly DevFest raffle. And just as a reminder, I believe it's case sensitive. So just be aware of that. I'm going to check the raffle form, see if anyone else has submitted, and share my screen. One moment. All right, so we have, there we go. We have a bunch of prizes that we're giving away today. A lot of GDG swag, Google swag. Again, for privacy purposes, privacy reasons, we're not displaying names on the raffle form. So feel free to enter. No one's going to know that you won. And it's numbers. The numbers correspond to a spreadsheet. Oh, just got one more. Let me just adjust that. Okay. Okay. And we're going to click this and see who won our next prize. Well, it's close. 39. All righty. 39 corresponds with John E. John, you're our fourth prize winner. All winners will be notified after the event via email so that we can get your address and send you a prize. So thank you so much, John. Congratulations. And now we can bring in our next guest. Here we go. So today I'm happy to bring to you Sean McQuillan, who is a developer advocate at Google. And Sean's going to be talking to us today about On the Road to Compose. So let's bring him to the studio.
Hi. Great to be here.
Sean. Thanks so much for joining us today. And I see we got similar microphone setups, so that's cool.
It was the one that still existed in stock in the
yeah, basically. Yeah, that's the same thing with the camera. So just a little housekeeping here. We have the question form that we'll be sharing with folks, and if there's any questions, I'll bring them up at the end to you. Same thing. I'll check the comments too. And when you go to share your screen, if you want to include audio, the best way to do it is to share a tab, just like you would if you were casting. And then there's a little checkbox that allows you to share audio. Otherwise, it doesn't really matter how you do it.
Okay.
Awesome.
Great. So let's go ahead and get started. Today, I'm going to be talking to you about Jetpack Compose. And I titled this talk back in January. And I think a more appropriate title now is At Home with Jetpack Compose. So today I'm going to talk quite a bit about, kind of how to think as you're using Jetpack Compose, as well as a little bit about like why we built it and what it is. I'm going to kind of try to leave some time for Q&A at the end. So if you have any questions, please put them in the forum or the chat, and I'll try to leave some time for addressing them at the end of the talk. So when the first question to ask with Jetpack Compose, right? So you probably heard about it a little bit by this time, is what is Jetpack Compose? So Jetpack Compose is kind of a new way to build UIs on Android. So it kind of basically takes this declarative model where you have this state of your application. Here I'm showing the state as a list of strings with emojis in them. And then Jetpack Compose's job is to kind of transform that state and figure out how to display it on the screen. So when I update the state, Jetpack Compose is responsible for figuring out how to update the screen for the new state. And if I keep updating the state, I'm going to keep updating the screen. And Jetpack Compose's job is to do that middle part right there, to figure out how do I convert my state into something that can be displayed on the screen. Now, the big question, this is something that kind of immediately comes to mind is like, why are we building Jetpack Compose, right? It's a new UI toolkit for Android. And we've put like a non-trivial investment into the existing UI toolkit, right? It's 10 years old. We've put millions of engineering hours of effort into it. So why are we working on a new UI toolkit for Android? Like, how is this helpful? And how is this something that, we can justify as like a good use of resources? And the answer to that really comes down to kind of the expectations of users on mobile changing over the last 10 years. When we built the original UI toolkit, it was for a very different world on mobile devices. People had quite lower expectations for the interactiveness and the complexity of UIs than they do today. Nowadays, users very much expect that UIs are composed of lots and lots of complicated elements. And they also they have this expectation, they wouldn't know how to describe it in programming terms, but they have this expectation that the UI correctly represents the state of the application at all times. So they kind of expect that when the state of the application changes, the UI immediately, possibly in the next frame, updates to display the new state in the UI to the user. And this expectation has led to a lot of good engineering practices, and we've kind of learned how to deal with this with the view system. But in some ways, we're kind of fighting against the grain in the view system when we're trying to build these very complex, very interactive UIs. And user expectations are very much that these things update very, very quickly. So Compose very much from the very beginning was designed to help build highly complex UIs that are kind of reactive. They interact with state to display it almost immediately. And this is going to basically make it easier to build these reactive UIs with less code and a more concise way, and a little bit more straightforward once you figure out the Compose paradigm. So where are we with Compose? So we launched it originally as kind of this open source preview. And at the time, I think you could display some text. I think there was some light support for fonts, and there was support for vector graphics, but not images. And then, so it was a very limited UI toolkit at the time. And then we continued to add more and more features. We did a developer preview. We did a developer preview 2. And each time we added more and more of the components you would expect in a UI toolkit. And we also sat down and did a lot of user studies and learned a lot about usages and misusages of the API and redesigned the APIs to be more fluent and more concise and more fit for the use case of building UIs on Android. Recently, we launched the alpha of Jetpack Compose. So what does this mean practically? This means really that that we've put enough stuff together that it's something you can build a real thing with. And we're seeing this all over the place, these cool demos on Twitter of people who've built like really interesting screens using the alpha version of Jetpack Compose. That said, alpha still means that the APIs are unstable. So there's things that we know we're going to build that we haven't built yet, such as a view pager. And then at the same time, we also know some of the APIs we built earlier on, maybe before developer preview, didn't kind of stand the test of time of user research that we've done since then. So we already know that some of the APIs are going to be changing, and we're going to continue getting feedback and doing user research. And there's, I would say that you should expect that any API in the alpha is possibly going to change before beta. So all said, Jetpack Compose is a declarative UI toolkit for Android built in Kotlin. And there's like a lot packed into this sentence. The big part is this big idea of a declarative UI toolkit. And what that means for Compose really is that you're going to declare a way to transform state into a UI. And then that transformation is going to be now the responsibility of Compose. And that's what we mean when we say declarative in the context of Compose. It's built for Android, and it's built by the Android team. So it's a kind of an Android first platform, and it's going to feel Android native. And it's also tightly integrated with a lot of the systems in Android as well. So it's capable of doing complex things like interact with cameras, using Jetpack Compose because the team is the same team that works on that other stuff. And it's built in Kotlin. So when you write Jetpack Compose code, it needs to be written in Kotlin, and it's designed from the beginning to be kind of a very Kotlin fluent API. So Jetpack Compose leans heavily on Kotlin. We see like core ideas in Jetpack Compose use advanced features of Kotlin. And we were able to do that because we decided at the very beginning to focus on what is the best UI toolkit we can build for Kotlin. So let's take a break from this overview and jump into a Compose 101. So this is going to be a kind of a very simple screen that we might be able to compose and take a look at how we'll do that. So I'm going to make a greeting composable, and then in there, I'm going to make a text composable. So there's a couple things that I note just like right off the top here. I'm capitalizing these functions. So I'm saying, capital G greeting and capital T text. And the naming convention for Compose is that the composable functions that emit UI are named after the thing they display on the screen. So this greeting composable displays a greeting on the screen, and the text composable displays text on the screen. And since they're functions, they can take parameters, right? So I can actually take a name as a parameter, and then I'll display a greeting for hello name. And here we can see I highlighted the capital G and capital T. The other important part is both of these functions are actually annotated with @composable. And this tells the Compose framework that these are special functions. These are functions that are meant to be run in the Compose framework to emit UI or do other composition-related things. So to actually use that over in an activity in my onCreate, instead of calling set content view, I can call set content, which is the way to enter into Compose. And then inside set content, I have a Lambda right here where I'm allowed to describe my screen using this Compose declarative DSL. So here I can say I'd like a material theme because I'd like to use the material theme colors and so forth from my applications theme. And then I'm going to display that greeting. So I just call the composable and I pass in the value I want to display. And so when I see it on the screen, it's actually going to display the composable. It's going to display the text. Now, it's not super pretty right now. So I want to go into that composable and see how I can decorate things in Compose. This is very similar to maybe view attributes in the view system. So on my text composable, it takes a modifier. And in that modifier, I can specify a padding of 24 dp. And I can also specify a style for the text. So I can say material theme typography H5, which grabs the standard typography H5 from my material theme. And when I do that, the screen updates to show me the new styling that I've applied to my composable. So for the next thing I want to do is I want to make a little shopping cart right here. So I want to make a kind of a list of things that I can add to a shopping cart and a plus or minus button. So this is a little bit more of a complex UI. It's starting to show a little bit of state, which is kind of like a very interesting topic. Like, how do I kind of represent state in this declarative UI toolkit? So let's take a look at kind of the simple way here, and then I'll spend a decent amount of time discussing state later in this talk. Let's see, sorry. So to get started, I'm going to go ahead and call that greeting composable because I can reuse that composable now throughout my application. So I'm going to make a cart and I'm going to call greeting, and I'm going to display hello up there. And then I'm going to make two pieces of state. This is the one I wanted. I'm going to make two pieces of state. So I'm going to make mugs and I'm going to make shirt. So these are both mutable state of, which is a compose specific state holder. And then I'm going to remember those in composition. And this is leaning on a kind of a special ability composable functions gain. They gain this ability to have memory, to store values, kind of similar to a property on a class. So here I'm saying this composable function cart has two pieces of state, one for mugs and one for shirt. And then down below, I'm able to actually use those state. I can say mugs.value and plus and mugs.value minus in the on-click handlers for those buttons. And then I'm going to do the exact same thing for shirts. And then down at the bottom, I want to show the total items in the cart. So to do that, I can actually just, in my composable, I have these two pieces of state, and I can just say, I would like to add them together. Right? This is a pretty simple transformation. So I'm just going to add them together really quick, grab a total, and I'm going to display that on the screen right here. Now, to actually see this, Compose has this feature in Android Studio called previews. So I can make a preview composable, and I'm going to name it my app. And this is also a composable function. And then all I do in here is maybe do some initialization if I need to, and then call through to the composable I want to display. And then over in Android Studio, it's actually going to display the screen, that cart composable for me, and I can add multiple of these to the same file, so I can actually preview quickly the different elements in the same file. Now, you may be, if you're kind of watching along, you may be a little bit suspicious about this state right here, and you might be right to be so. There's kind of a mix of logic and state and UI presentation all going on in a single composable. And is that a good idea? Is that something we want to do? And the answer is maybe. And to discuss that, I'd like to just discuss state and compose kind of from the top. Let's take a look at like what state in a composable looks like. So I'm going to take a huge step back and talk about what state is, because I think this is one that is worth like thinking about from first principles. So state in a programming application, in kind of an Android application or even a web page or a desktop application, is any value that changes over time. All right, and this is an incredibly broad definition. This covers everything from the mugs I showed on the previous slides, all the way over to like a value from an accelerometer, which is a piece of hardware that's actually reading some physical metric on the phone. And it's important, I think, at this point to kind of think about state as its purest principle. So then we can, as we pull it into Compose, we can see what restrictions does Compose put on state, and how can we kind of think about modeling this abstract idea of state in a way that is usable to build declarative UIs. To do that, I'm going to talk about two different ways. I'm going to talk first about how I might think about state in kind of a hybrid application scenario. And then I'm going to dive in deeply on the actual creation of a composition, the way that Compose actually runs. And then we're going to talk about recomposition. And in there, we're going to talk a little bit more about how to effectively interact with state inside of a composable. So to get started, the big idea of Compose from the very beginning, at the intro, I introduced this idea we wanted to make reactive UIs. And the best way we know how to do that is to use unidirectional data flow. And Compose is built from the beginning for unidirectional data flow. And it works best if you use unidirectional data flow throughout your application. Now, this is a kind of a big concept, unidirectional data flow. What is that? So I'm not going to answer that right now. We'll come back to that at the end of the section. But let's take a look at an example of that before we define it. So I'm going to make just the buttons into a separate composable here. I've kind of just extracted just the plus and minus buttons and the text from that cart we were looking at before. And then what the desired behavior here is when the user clicks on that 3, that it clicks on the plus button, the 3 turns into a 4. Now, if I was in just a regular old activity, right? Let's just ignore compose for a second. One way I could write this code is to go ahead and in my activity, just make a little mutable variable called count. And it's an integer and it initializes to 0. And then down in the minus click listener, I can subtract count. And then I can call a function that I define called update count. And then similarly in the plus. And then an update count, all I do is I just bind that text to the new value of count, whatever the current value of count is. Now, this pattern, and for this very small example, this pattern is fine. But we found, I found this, and a lot of other developers have found this as well. It doesn't really scale very well as your screen gets more complex. And the reason for that is we've kind of coupled together a lot of different things. Particularly, we've coupled together our state, the updating of their state, and the displaying of our state. And also because we only have this one activity to put things in, the activity tends to just grow tons and tons of these little state variables and lots of little logic related to these callbacks. So a couple actual failures that can happen in this scenario is I can forget to update a state that I should have and lead to kind of this inconsistent state scenario inside of one of my click listeners. And then the other thing that can happen is in a click listener, I may update some state, but not call the appropriate update function. So it's very easy to either have inconsistent state or to have state get updated and not be displayed to the user. And so to fix these things, we actually introduced ViewModel a couple of years ago. So ViewModel really kind of helps with this sort of state thing that we're doing right here. And what I want to talk about here, this isn't really an architecture talk, this is more of a meta architecture talk right now, is that the way to think about ViewModel, what were we doing as we built these APIs? So first of all, we have this count live data. So I'm going to take that count, I'm going to pull it out of the activity, and I'm going to put it into a ViewModel. And I'm going to do that by using a live data, which represents the state of the UI. And so this live data is an integer, and it's an integer that I can then display directly in my UI. I'm also going to define an event. I'm going to define an event for increment. And in a ViewModel, the way I express that commonly is through just a function. So I'm going to make a function increment that is going to do some processing and then potentially update state. Similarly, I'm going to have an event decrement, which is going to do some processing and then potentially update state. And this is kind of the core of the way that ViewModels are designed, right? There's observable state, which we have here as a live data, and then there's events. And if we kind of model this, if we draw a diagram and put the ViewModel on top, we can see that the state flows down from the ViewModel, and the events flow up from the activity into the ViewModel. Now, over in the activity, I can go ahead and use those on-click listeners. And now, instead of directly modifying the state in the activity, all I do is call the appropriate event over in the ViewModel, right? So now I'm really thinking about my ViewModel is getting state or events passed up to it, and my activity is getting state passed down to it, right? So I can observe that live data and display it on the screen. And when we run this, we'll see that it actually displays what we expect. So this is a very big concept. This is kind of what ViewModels do for activities, and we're going to find out this is very important in Compose. And this concept of state hoisting, which is to move state up to make a component stateless. And the kind of general idea of this is to think about taking a state holder and moving it up out of the UI or out of a particular piece of UI, and then have the state move down from that state holder, and an events flow up to that state holder. Events do some processing and maybe update the state, which then updates the UI again. So while preparing for this talk, I did kind of a survey of all of the different modern architecture patterns and checked to see how strictly they followed this idea of unidirectional data flow. And we can see that all of the ones that have gained popularity over the last couple of years, MVI, Mavericks, MVVM, Guide to App Architecture, Android Architecture Components, really promote this idea of unidirectional data flow, where state strictly flows down and events strictly flow up. Now, what does Compose consider state? Let's transition this out of the view system and over into Compose. In Compose, state is any observable value that updates its listener every time it's changed. There's a lot packed in this definition. Let's start with observable. So what is an observable? This is something that if you've used a bunch of them, it may seem obvious, but it actually turns out it's kind of this like pattern that unless you've gotten it, it's a little confusing. So an observable really is just any object that represents some state, which is a thing that can change over time, that provides a method that allows anyone else in the application to observe changes to that. So on a live data, I have an observe method. On Stateflow, I might use like a collect method. But the key idea of observable is some other part of my application, such as my activity or somewhere else, can observe changes to this value by calling some method and passing a callback to get notified of changes. Another important part is it updates its listeners every time it's changed. Turns out to be really important in Compose. If you have an observable value that only updates the listeners sometimes, it turns out Compose can't use that because it can, but what'll end up happening is all of the values that don't actually get emitted, that don't update their listeners, won't be reflected on the screen by your composable functions. So let's take that view model, and we're going to take that exact same view model here. And what we want to do is swap the activity out for composable. So we're not going to change anything about how our view model is implemented. We're just going to try to integrate this with Compose. And this is very much what you might do if you introduce Compose kind of one screen at a time in an existing Android application. You just leave the view model at the fragment level, and then pass values down into Compose. So let's see how that works. So I'm going to go ahead and make I'm just going to make a call to cart screen, but now I'm going to pass a view model to it. So let's see how that's going to work. And what I'm actually going to do is I'm going to make a composable that's entire job is to kind of interact with this view model, and then stop passing the view model down to the rest of the composables. And this is actually going to make kind of give me some wins, and you'll see why as we continue with this talk. So to get started, I have to read that count off the view model. So the way to do that in Compose, I just say viewModel.count, and then I have this function observe as state. And this is kind of a new thing. And then I'm also using this by keyword from Kotlin. So this is a lot packed into this one line. Let's kind of like take it apart, tease it apart a little bit, and see what's going on here. So this is very much the same as what we would do in the view system, where we say live data.observe, and then we pass it a lambda. But similar to coroutines, composables give us the ability to kind of flatten these callback type behaviors. So instead of actually passing a lambda for the rest of the composables to observe a state, I'm actually able to make observe a state return a value every single time that live data changes. So like we can kind of think about this as basically exactly equivalent to what we did in the view system with live data.observe. So then what is the rest of this doing? So observe a state is actually going to take a live data. It's going to set up an observer on it. And then it's going to basically transform it into a state T, which is a observable type that Compose knows about and is deeply integrated with. Then we have this by function right here. So this is just a property delegate, which is saying to Kotlin to go ahead and call get value or set value. So we can actually treat the state T variable as just a regular integer. So then after all of this is said and done, in my composable, I've taken this observable state hold with this live data, and I've just transformed it into a regular integer that is the current value of that live data all the time. And it's going to rely upon Compose's ability to do declarative UI programming to keep that value up to date and call this function again whenever it needs to be called because the live data changed. So now I've extracted some state, and it's just a regular integer. So I'm able to just, from now on, I can ignore the fact that it came from a live data. I'm able to just pass an integer down to my actual cart counter. Then I'm also going to give two events. I'm going to pass the viewModel increment and viewModel decrement. So these are the functions that I defined earlier on my viewModel. And now we can go into the cart counter screen, and we'll see that we have a state, which is just an integer. And then I have an event, which I have two events on increment and on decrement. Now, I want to pause right here and just say there's like a lot that I can get out of this function declaration. In Compose, everything's a function. So reading the function declaration is often incredibly important to understanding what a composable does. So I can tell already this is a composable because it has @composable, and it's going to emit UI because it has a capital C on cart counter. And it also returns unit, which means that it emits UI because you aren't supposed to emit UI from composables that return a value. And then it also takes these 3 parameters: count, increment, and decrement. And from some pattern matching, what I can kind of guess is this cart counter is going to display something based on this state, right? Maybe it's going to display a list of items. Maybe it's going to display the value, but it's going to display the count. And these 2 functions, on increment and on decrement, are requests by this function to modify that count that the caller can then go execute. So I'm able to use that state to actually display the text here. So I can just take that state, it's just a regular integer, and I can go ahead and display that directly to a text composable. And I also can pass those events straight to buttons here. And when I do that, I've got like wired up my entire unidirectional data flow, and I've gotten this composable to be correct. So let's take a look at the unidirectional data flow. So we have a view model, and it definitely has state going down to cart screen and events going up from cart screen. And now we've added this new composable card called cart counter. And when we did so, now we still have state going down using that count parameter. And then we have events going up using on increment and on decrement. So we've managed to add yet another level to our composables while preserving the whole unidirectional data flow of this screen. And if we run it, we'll see that when we click that, 3 becomes 4. So now that we've kind of explored this, we can see that this is like now a complex 3-part problem with state flowing down and events going up. And we can start thinking about unidirectional data flow again. Unidirectional data flow is any design where state flows down and events flow up. And you'll notice that I was kind of careful with the choice of the word design here, and I didn't use the word architecture. And that was intentional. It turns out in Compose, unidirectional data flow is this very core concept, and it applies all the way down to the way you structure a single composable and all the way up to the way you structure the architecture of your application. But no matter how you're using it, you should be able to draw some picture where you can put the things that hold state on top with state flowing down and events flowing up. So now I want to switch gears a little bit and move out of that hybrid world and into talking directly about composition. So what happens when I call set content on this? What happens when I call cart screen? And I think it's useful to think about. I think it's useful to actually just go ahead and trace this execution and see what Compose is doing. So it's going to execute these things just like a regular function. So it's going to go ahead and call it from the top, and then it's going to go ahead and then call cart counter. It's just a regular function. But what you can see Compose is doing over on the right-hand side there is it's actually kind of keeping track of the composables that I called to describe my screen. It's actually going to build like a little tree out of these composables. So then in cart counter, it's going to call row, and the row has a button which has a text, and then there's another text for the count, and then another button that has a text. And so this is actually what Compose is doing when it runs composition, when it's generating a composition. So what it's actually doing is keeping track of the composables that it runs to describe the screen, and it's building basically a little tree out of them that it can use then to figure out how to actually display that. So what is composition, right? So it's a description of the UI, and it's built by Compose when it executes composables. And it has like roughly a tree shape, and that's basically, you can kind of think about it the way I just diagrammed it before. This is a nice definition. This is one that I've hashed out a couple times, and I think it really kind of encapsulates all of the core ideas of what a composition is. But what I kind of think about composition as is converting parameters into a UI. All right, as I'm actually coding in Compose, what I'm thinking about doing is I have a bunch of parameters. I have a bunch of like application state, and I need to convert that into UI, and composition is the process for doing that. So now that we've talked about composition, let's jump into recomposition. Recomposition is kind of the magic of Compose. It's how the declarative part works. So recomposition is running the same composables again with new inputs. So in order to do that, Compose kind of heavily relies upon this thing called state of T. This is an observable value holder that drives recomposition. So what I want to do now is I want to just like drop the view model. I want to drop all the architecture we talked about before and build this cart counter directly in Compose like we did on the intro slides. So to do that, I'm just going to go ahead and make a count here. And I'm going to use by remember and give it a mutable state of. And so when Compose executes this, it's going to call it from the top just like a regular function. And then it's going to get into this remember. And what it does here is it actually gives this composable a bit of memory. And it stores that single slot of memory over in that tree that Compose has been using to track the composables. It allows us to store some values in there as well. So the next time cart counter gets called, instead of producing a new mutable state of, it's actually going to fetch the one from that tree and give us back the same value over and over and over again. Now, that's you might notice also I'm storing a mutable state of, so I'm saving the same instance of mutable state, and this effectively gives this cart counter composable state. So now there's a cart counter composable, and it has this current equals 0, which is like basically exactly the same thing as a private variable inside of a class. And then I'm going to go ahead and call through to row. And then when I get to the text, I'm going to go ahead and display the count and then do the rest of it. So we've only really made one composable here, but you can see that we actually generated this large screen, our large composition that we can take a look at. And actually, even though there's only one composable here that's interacting with state, we can even do a unidirectional data flow analysis of this. So we can check, is this following unidirectional data flow? And we can actually see that the state is flowing down from cart counter into text, and the events are flowing up from those buttons up to cart counter. So this passes the unidirectional data flow that we're trying to do for Compose. And when we run that, we'll see that it displays. And then what happens when the user clicks on this button? So when that happens, it's going to go ahead and call this callback. This is just basically an on-click callback. It's a Lambda you pass to Compose, and it kept track of it. And when it figured out the pointer happened on that button, it goes, oh, let me call that on-click callback, just like it does with a regular button. And in there, I'm able to go ahead and call count plus equals 1. So I'm able to say, increment that count state that I'm using as my state variable for cart counter. And when I do that, it goes ahead and it marks current as dirty. But then it actually just kind of stops executing. At this point, Compose is paused, and it has kind of a note that there is some dirty state inside the composition. So it basically needs to go then figure out how do I update the screen. So the way that I'm going to do that is if I'm Compose. What Compose is going to do is it's actually going to look for all of the places where that state was read. And that was actually caused in this code by this call to by, which calls get value, which reads the state. So when we have the state read right here, Compose is going to go, okay, that composable is in fact dirty. Let me go ahead and re-execute that. So it just goes ahead and it just calls the function again from the top. This process here is called recomposition. But now it has new data. So it's going to run cart counter, then it has to run row as well. And then it's going to run the text composable, which of course it has to do because 0 has turned into 1. So the text composable has to run again to display the new value. And then it's done. Compose is able to, through the compiler, figure out that the rest of these composables can't possibly have updated due to that state changing. So it's able to skip those. So we've managed to kind of like get this optimized behavior just kind of for free, which is really, really nice. So that's recomposition. It's running the same composable again with new inputs. And there's kind of this like really interesting caveat here. A lot of people, including me, when they first get exposed to Compose, start thinking about recomposition as maybe a replacement for RxJava, and it's really not designed for that. It doesn't work very well. And it's important that Compose is trying to build this composition tree, and it's not actually interested in being a general restartable function framework. So there's a couple rules that come out of this, which is Compose may run, or recomposition may run every frame for a single composable. And this happens commonly in the case of animations. Or it may run never. Like you may do an initial composition and then a composable never updates any state that would cause it to recompose. So that composable only ever runs one time for the entire lifetime of your application. So as a consequence of this, you should never depend upon side effects for recomposition. And so What this really means is, like, as you're using it, think about converting parameters into UI. Don't think about trying to use Compose as a replacement for RxJava. And so we kind of like, next thing I want to talk about here is state hoisting, which is moving state up to make a component stateless. So I want to use that row that we've made with the minus and plus button, and I want to put 2 of them on a screen, and then I want to display the total. So when I start writing the cart screen, maybe I'm going to put 2 cart counters in, and then when I try to put that total line in, I'm going to run into a problem. How do I actually get this total, right? The states are stored down in the cart counters. Now, there's a couple of ways that you might think to try to do this. The first thing you might think is, well, you know, I have the state, it's just a variable, it's just an integer in my cart counter composable. I could just return it. And in fact, the compiler will let you do this. But let's go ahead and check the unidirectional data flow for this composable right here. So what we can see is the state is still held by cart counter, but we're actually passing state up. So when we do that, now the state is going up, which is not what we want to do for unidirectional data flow. So the next thing you might be thinking is, well, I've been paying attention. What I really want to do is move an event up. So let's make cart counter take on count changed event. And then I'm going to go ahead and every single time this recomposes, I'm going to call on count changed. Now, this is effectively a side effect of recomposition. This code is actually not safe, and you very much should not do this exact code. But there's a bigger issue, which is, let's go ahead and take a look at the unidirectional data flow right here. Even though we called this on count change, we haven't actually added an event. What we're doing here basically is taking state, which is still owned by cart counter, and we're sharing it with cart screen through this callback. So what this really is state going up. So this really isn't following unidirectional data flow. So let's take one more stab at this, and let's see, how can we actually move this state up to our parent? So what we really want to do is literally take this state variable and just move it into our parameters and let our parent pass it down to us. So to do that, the general transformation, you can apply this to any composable, is to replace a single piece of state with a variable of type T and an event, which is a change event from T to unit. Right, so here I've taken the count variable and changed it for a count of integer, and I have an on count change, which is integer to unit. And let's check our unidirectional data flow for that. We can see we now have state flowing down from cart screen. The state is stored in the cart screen, or even higher if it wants to be. And the events are going up to cart screen. Now, this is just the first pass. We can actually keep going here. We don't have to stop with on count change. If there's better events to describe the events from your composable, you can make those as well. So here we can say count, on increment, on decrement, and you'll notice this is exactly where we started. So let's just swap out the rest of the code. So to kind of wrap up, let's talk about local state versus hoisted state. So local state is internal state to a function, and hoisted state is caller managed state used by a composable function. So local state is basically exactly equivalent to a private variable in a class, whereas hoisted state is publicly owned. It's owned by someone else. It may be encapsulated by someone else, but it's not, from our perspective, it's not something we have much control over inside of a composable that has hoisted state. Instead, someone else is responsible for encapsulating and dealing with that state, and they can do literally whatever they want, including just not actually give us a state variable, but just pass us the number 3 all the time. With that said, local state is non-interceptable. If the caller needs to modify the state or change the behavior of state updates, they really can't do it, right? It's a private variable on a class. There's very little you can do to get in there and poke at a private variable on a class. Hoisted state is directly interceptable. So for this shopping cart example, I may want to store these cart totals in a room database. And with hoisted state, I can totally do that. I can actually pass that up to a view model, and then from a view model, pass it all over to a room database, and then just display the count from that room database instead of from sort of in-memory state like I'm doing right now. Local state should be reserved for implementation details. These are most commonly animations, but there's many situations where it comes up where it's an implementation detail of some composable that has state, whereas hoisted state is trivial to test, is like kind of the exact opposite. It's very much a part of the public API, so it's very easy to control the hoisted state, intercept the hoisted state, and write tests about it. And then local state is not shareable. If I want to share local state with multiple sibling composables, there's no way to do that. Whereas if I create hoisted state, it's very easy to then hoist that up to the appropriate level and then share it with all of the relevant composables. So that said, it's okay to have internal state. There's a lot of situations where it happens. You're definitely going to do it all the time for animations. You might do it for like checkboxes. And as you start actually getting into full Compose applications, you might add internal state for view models. For example, you might have like a navigation component, and then underneath that, you might have screen composables. And those screen composables may have internal state of a view model, and that's totally fine. So thinking back to effective Java, there was this really good principle: classes should be immutable unless there's a very good reason to make them immutable. And this has really stood the test of time. This is, here we are 20 years later, I guess, on effective Java. And this one is still very, very relevant. It's still a really good idea. And the reason I think this is done so well is it's only kind of opinionated. It's basically saying, if you don't have a good reason, make your classes immutable. But then in practice, there's good reasons all the time. So it's okay to make them mutable as well. So it just basically is a preference towards immutability. And I think this translates very, very well to Compose, which is composables should be stateless unless there's a very good reason to make them stateful. So to wrap up, I just want to say Compose is built for unidirectional data flow. And by doing that, we're able to build richer, more complex UIs that are reactive and respond to state changes for the user very, very quickly and give this beautiful user experience. And Jetpack Compose is a declarative UI toolkit for Android built in Kotlin. We're currently in alpha. If you want to learn more, check out the landing page. There's a whole bunch of great content, including a pathway you can find links to from there. And if you have any feedback, please send it on Google/Compose feedback. Thank you. And let's see if we have any time for Q&A. Sorry, I can't hear.
Sorry about that. All right. So we do have some questions. And I will start with an easy one.
Oh, okay.
The first one is the mug in your slide available to buy?
That was, I apologize for that. That was for AndDev 360, which is the first conference I gave this talk at. And I didn't catch it when I was updating the slides. When I was on the slide, I was like, oh no, I have the wrong conference's mug up. Yeah. But yeah, I believe you can find the AndDev 360 score. Hit me up on Twitter if you want me to find a link for that for you.
Okay, cool. Thank you. Okay, next question. Here's another easy one. Will the slides be available later?
Unfortunately, no, I don't think so. For this talk, the slides are actually kind of a mess internally. Sorry about that one. Okay. But I would say a lot of the content that I covered today, there's a draft developer.android.com page on state that's happening that should be going out relatively soon. It's currently going through some reviews and some drafts and whatnot that covers almost exactly the same material I covered in this talk. Okay,
cool. Do you have an ETA on when Compose will be out of alpha or beta?
We don't have a public one, but we're working very hard on it. There's people are trying to get it out the door, is what I can say.
It looks like there's a couple other questions similar to that. Okay, it's a long one. Compose, although it might be an alpha, it is powerful enough to create advanced animations already, and when it comes to a stable version, it will come packed with even more features. For anyone like me who is starting out on Android animations, would you recommend starting with Compose? And if not, what other tools would you advise for us to try out?
Yeah, so there's two answers. If you're absolutely brand new to Android, you may be able to go all in on Compose, but practically, I don't really think there's going to be that many production apps using Compose until late next year, just because of the pragmatics of adopting some technology like this inside of a company. So it's probably a good idea to also learn the view system if you're just starting out on Android right now. The animation tools that I would definitely point you towards in the view system, motion layout, which is based on constraint layout, is also something that we're putting out right now. And it comes with a motion editor that's built into Android Studio. And I would definitely point you in the direction of checking that out. If you're interested in doing kind of canvas-based animations, those are completely possible in the view system as well. They're quite a bit easier to express in Compose. So if you're just kind of tinkering with that, I would definitely recommend doing that over in the Compose land, because it's just a lot more fun to do canvas animations over there.
Okay, cool. And you actually answered another question just with that answer, so that's great. Do you have some examples of apps that have switched to Compose and seen benefits?
So let's see. The only one we've really done kind of this interop thing where we took an existing app and moved it was Sunflower. And I can't list. Yeah, we haven't really tried to study that one to give me a talking point for this one. But what I can say is, like, when I build Compose screens, there's two things that are like wildly better. So the recycler view story in the existing view system it's just a lot of code. The adapters, the view holders, wiring that all up. And then when you do use recycler view correctly, it basically follows unidirectional data flow in the same practices we use in Compose. But it's just kind of a lot of code, and it's kind of mixed with classes, and it feels like a little cumbersome. In Compose, that whole thing is replaced with a thing called adapter list, which takes a single lambda and then describes basically your view holders, and is capable of responding to state changes and following the entire unidirectional data flow pattern that I showed here. So in practice, this means most recycler views go from something like 2,000 to 3,000 lines of code down to 10. Which is just wild. So that's like a really fun one. And so I would point you to the State Code Lab if you want to see that in practice. So the State Code Lab, which is not about recycler views at all, is able to use these APIs to build an animated interactive recycler view as part of just a side effect of exploring state. So that was really exciting to me when we were able to land that. The other thing that I would say is just like overall, by moving into this unidirectional data flow pattern, the view system is no longer fighting against you as you try to build like complex reactive UIs. So instead of like having state down like you do in an edit text, where you're basically just constantly fighting the edit text for the control of the state that the edit text keeps track of, and you have to unregister and re-register the listener and all of this stuff in order to make that thing work. You just get to move that state all the way out of the edit text and up into maybe your view model, and then you basically get complete control over the state that's displayed on the screen and the updates to that state. So you no longer have this kind of dance where you're like fighting against a view system that's trying to maintain state and trying to tell it, hey, please stop, I already have the state somewhere else. So overall, the code ends up quite a bit simpler for situations like that. Other situations that are very important, navigation, currently in the navigation component, because it's integrated with fragment transactions, has non-idempotent APIs, and we've pretty much scrapped all of those as we started going into Compose. So this is something where it's very difficult currently to put a navigation destination in a view model without putting some more code around it. With Compose, it's incredibly easy to build a state for the current navigation destination and just have the screen get updated accordingly as appropriate.
Cool. All right. Two questions that are actually related to each other. I'll try to join them. Okay. So for an existing app, what is the level of effort to switch to Compose? Mm-hmm. And I guess when would there be ROI in doing so? What's the curve? And then also, do you have to migrate your entire app?
Those are good questions. So the first one, what is the level of effort? So in practice, if I kind of think about this from the perspective of, let me make an imaginary app so I can talk about a concrete example. Let's make an imaginary app. It's using a single activity. It's using multiple fragments. It's maybe using multi-module and it's using the navigation component. So the things that I'm probably going to do for a migration for an app like that is one screen at a time. I'm going to go ahead and swap out the view layer and pretty much all of the code in my fragment for the same code written in composables. And then as I do that, I'm going to extract out a design language for my application. So I'm going to be building reusable composables that describe the UI elements for my application, so I can reuse them on different screens. And by the time I'm like maybe halfway done and I've done like half the screens, I should be in this situation where building a new fragment is literally just grabbing 10 composables that have already been made for other screens and just dropping them on the screen, and then maybe one unique thing that's different on that screen. So overall, like the big migration story is it's probably going to be one screen at a time. It's probably going to be at the fragment of the activity level as you have in your application. Then as you go further along that path, you might get to the point where the majority of a section or an entire section of your application is all in Compose, at which point you might actually move the navigation into Compose as well, which gives you some advantages around the ability to share, state and stuff like that. And it also gives you some advantages around ease of doing some styles of animations that are very difficult to do in the fragment system. Shared element type things are possible to do in Compose in a way that are they're also possible in the fragment system, but they're a little bit more brittle in some ways. So what was the second question? I'm sorry, that was all about.
Yeah. So do you have to migrate your entire app? And I guess at what point is there a return? It sounds like just based on the amount of code that you're going to reduce, you get an immediate return on the investment.
Yeah. Yeah, so I would say, to be super pragmatic too, if I'm thinking about this from a big company shop, if I'm at a bank or something like that, there's going to be probably, I would guess, 3-4 months of early investment, just figuring out the architectures that I'd want to do, socializing that to the team, writing up design docs and training. So the bigger the company, I think this is going to take a little bit longer. And you're probably going to want to get some of your foundational architecture for how a screen is structured before you do your first port. That's a really good practice there, is to do some prototyping, to go and maybe try to make some samples while you're working on those company-wide architectural guidelines, because it does take a little bit to kind of learn Compose yourself. So if you try to write the architectural principles coming straight from the view system, you might make some misses that you'll regret later. So try prototyping them out in small little refactors that maybe you don't check in, but you just discuss as code as you go.
Okay, cool. Thank you. Just, I think 2 more, maybe 3. Okay, here's another long one. How much does Jetpack Compose inherit ideas and architecture or even components from Flutter? Does Compose have any connection behind the scenes with Flutter?
So we're both Google products, Jetpack Compose and Flutter. The big difference is Compose is made by the UI Toolkit team at Google, and it's basically heavily invested in being an Android declarative UI toolkit. It's also invested in using Kotlin to integrate with existing application code on Android. So should be a very smooth interop migration, similar to what we saw with Kotlin when people first adopted Kotlin in the Android ecosystem. There's a lot of discussion. We definitely chat a lot, and Flutter had a lot of really good ideas. So we definitely started from a lot of the same place that Flutter did. And you can see some really inspired APIs like Scaffold is very much inspired by meetings and discussions we have with the Flutter team about what's a good API surface for this. And as we moved it into Kotlin, the actual specifics of the APIs often change pretty substantially compared to the Flutter version. But the original inception often comes from discussions with the Flutter team about really good ways to solve these problems. Fundamentally, we're very similar systems in that we're both declarative UI toolkits that kind of follow this unidirectional data flow model and kind of promote intentional thinking about state. Flutter goes a step further, and they have a stateful component versus a stateless component as their root classes, and that would be the equivalent if you had a stateful composable annotation or something like that. We collapsed that a little bit because we found that in practice you end up putting state where state needs to be, and once you get your head around state hoisting and unidirectional data flow, it becomes very natural to go this is the right composable to put this animation state in and stuff like that.
Okay, very cool. We just got another couple questions. Sorry. Okay, you just talked about state hoisting, so let's go ahead and go to a question about that. Would you say state hoisting is something like Flutter inherited widget?
I don't know Flutter that well, unfortunately. Okay. State hoisting. So this is a kind of a universal declarative UI toolkit concept. And it's in Flutter, they use this concept, the same concept, they call it state lifting. And in other frameworks, sometimes it's called, various things where they use the word props. So it basically is this idea of I have a stateful composable, but I want someone else to be able to interact with that state in some meaningful way, because this composable isn't the correct owner of that state. It's really just kind of a display composable. So I'm going to come up with a pattern to move that state into my parent, which pretty much always means making the parent pass down parameters that control and determine that state.
Okay, Cool. Okay. I mean, it obviously is a popular topic because we have a lot of questions. Just I think one or two more. How do you unit test Compose-based apps?
So right now, the answer to that really is that in order to run Compose, you have to use instrumentation tests. There is a unit testing framework built into Compose, which is the unit testing framework we use for building composables. And it's also if you're kind of like reacting to that, like the way that personally I was like, oh, instrumentation tests, yay, when I first heard about that. It turns out it's like actually a very different experience than when you're testing the view system, because there's less involved in a composable. So the view system, typically when you do an instrumentation test, you're talking about very heavy dependencies on usually an entire view file for an activity. You're also dealing with dependencies on like a whole bunch of random system services. Whereas in Compose, if I wanted to do something where I'm unit testing like that click counter example I did there, really all the code that's running is the composables that are generating that click counter. And all that's happening there is it's just going to generate that composition tree that we kept talking about in the talk. And then it also generates a semantics tree, which is like what I'm going to run my assertions on. So there is a unit testing framework built into Compose. There's some discussion, and I have hopes for some off-device testing story for Compose. But fundamentally, once we get down to the point where we're testing things that display UI, testing that in the highest fidelity environment is a really good idea. There are fundamental differences between the way x86 processors and ARM processors work. So running code that is that integrated with kind of the platform is on the right processor is a good idea.
Okay, cool. Okay, last one for hopefully for now. Are there any other libraries besides material design that we can use with Compose?
So we're building, so this is actually really good. I didn't cover it in this talk, but Compose is built on a layered architecture. So material components is, we set out from the very beginning of Compose to ship a solid material components library because we are aware that's kind of a shortcoming of the current UI toolkit. We have the material design components and they're very awesome and I love using them. But then like sometimes you end up with like an unstyled thing or you end up with like a mystery style coming from somewhere. So we wanted from the very beginning to make the experience of building a pure material application absolutely like fluent and like a first-class experience in the UI toolkit. So there is a material component, and that's like when you make a button, you very typically grab the material button because it looks nice. It has like lots of nice features. It's a pretty button. That said, there's two other libraries in Compose, right? So there's Foundation, which is what Material builds its components on top of. So it's going to have all of the components, all of the basic components for building a toolkit like a Material component. So it's going to have everything for displaying text. It's going to have everything for, I believe some of the stuff around dealing with gestures is in there. So it's that library is the one, when you start building non-material components, that's the one you want to reach for. And then below that, there's the core library. And core is the very lowest level. So if you wanted to do like maybe a word processor, that would be the level to go look at as well, where you're starting to deal with, I want to get high performance, I want to get very specialized behavior out of my composables. So to recap, there's core, which is the lowest level, well, lowest level is down here. There's Foundation, which builds on top of that, which is a good API that you should be comfortable reaching for when you're using Compose, and the Material, which wraps up Foundation with the material design guidelines. We are only shipping the Material as a design language, but personally, I expect applications will build their own Material-like components for their own design language, and I also hope to see people, kind of wrap these things up as libraries as they come up with some cool button or something like that.
Very cool. I'm going to just make the request now. I would love to see a study jam on Compose. So hopefully we can get materials to do that, because it sounds like a lot of our members are really interested just based on all the questions. And I know I'm interested based on the talk. So I'm putting in my 2 cents. I'd love to see a study jam come out for it.
All right. Well, I'll pass that along and see what we can do.
Great. Well, thank you so much. Really appreciate it. And if anyone has any further questions, we'll relay them on to you.
Awesome. Thank you so much.
All right.
Cheers.
Have a good one. Thanks for joining.
Bye.
Bye. All right. So let's do another raffle real quick before we do our next talk. Let me share my entire screen. Here we go. All righty. So again, that was Sean McQuillan, developer advocate at Google, talking about Compose. If you haven't already entered, please enter our raffle at bit.ly/DevFest raffle with a capital R. And I'll give you a couple seconds to enter if you haven't already entered, and then we'll switch to the wheel and do the raffle. Last chance. Some other things to note. Today's event is brought to you by many of the GDG chapters here in the Pacific region. You can learn more about the GDG program and find the chapter closest to you by visiting gdg.community.dev. I'll pull that URL up. There we go. Oh, we got another raffle entry just in time. All righty. And just also a reminder, this event is being recorded. Let's switch over to the wheel. And let's see who our next winner is. All right. Oh, 67. Congratulations to Doug M. in the Redwoods. Doug, you are our 5th winner today. And as I mentioned earlier, we'll be notifying everyone via email that they've won, and then we'll ship out your prizes to you. Okay. So just a reminder, we are live streaming. Keep the comments clean. Our code of conduct, again, is to be excellent. So we have a 0 tolerance policy. If anyone says anything that is inappropriate, let us know. You can let us know on our Q&A form, which is bit.ly DevFest Q with a capital Q. Please also submit questions to our speakers there as well, and then I'll read them after the talk. Here we go. And now I'd like to introduce our next guest. Bob is giving a talk on semantic search on GCP. Let's bring him into the station. Here we go. Bob, you there?
Yes, I am. Thank you.
Awesome. Thank you so much.
Good afternoon, that is, I think, for you, right? Or good morning?
Yeah, we're on the west coast of, or at least the Pacific region, so it's good afternoon here. It's good morning for you, right?
No. It's 10 p.m. in the at night.
Okay.
Yes,
well, good.
Yes.
Thanks for staying up late with us. We appreciate it. So everyone, you're in the Netherlands, is that right?
Yes, that's correct. Near Amsterdam.
Yeah. Okay. So yeah, Bob's an international speaker. He's given talks all over the world. So we're very lucky to have him tonight. So Bob, I don't know if you're familiar with StreamYard, the tool we're using today, but you'll be able to use the share screen button at the bottom to share your screen. Are you going to want to use any audio from the presentation or anything like that?
No.
Okay, then any of the options that you choose to share your screen will work. I'll also control the camera angle and be able to kind of have you speaking. I'll try to not block any of your slides or anything like that.
Perfect. Thank you so much.
Yeah, of course. Thank you.
So here we go. Yeah. So first of all, thank you for having me again. I saw your beautiful introduction. There was a minor thing is different though, and that's that I'm a developer expert. So that's a little bit different, but it's just a minor difference. And actually, I work for a company called Semi Technologies, and we do a lot with Google technology. So hence the talk here. So what I'm going to do is I'm going to talk a little bit about Weaviate, the Weaviate search engine. I'm going to talk about what it is, what problem it solves, and more importantly, I'm going to give 2 demos. So the first thing is the demo that I'm going to give first is I'm going to give some example queries that you can see what makes Weaviate different. And then I'm going to give a getting started demo so that you can actually get started yourself if you like what you see. So first, a little bit about the problem that Weaviate aims to solve. So we have a lot of great search engines around, and I'm not talking about a search engine like Google Search, but I talk about search engines that you can actually integrate on the data level in your applications. They still deal with 80% of the data that they deal with is unstructured. And the problem with unstructured text still is that it's difficult to classify data. So if you want to classify data in unstructured text, the easiest way to do it is through keywords, maybe different technologies or approaches, like for example, fuzzy searches are possible, but it's still difficult to actually classify unstructured text. And the reverse is also still an issue, right? If you want to search through unstructured text, and especially if you want to do that on a large scale, yes, we have great search engines where we can find data based on keywords, but it becomes a little bit more difficult if we want to do that more on the meaning of the text. And that's actually and if you look at how the problem currently is solved, then we see often that search is enhanced by adding machine learning capabilities to existing search engines, or through manual effort, so that people actually manually tag data, or in the case of classification, we see that data scientists actually label data, or it's again a manual effort. And the problem with that is that adding machine learning capabilities to status quo search engines is not very scalable, because you still use the traditional search engine to get the results, and then you often sort them with a machine learning model. And if you have data scientists that actually need to do the labeling for you, that's not only expensive, but that's also, if you are a data scientist, that's the part of the work that you don't want to do, right? So you actually want to build your models. So and let alone the manual effort. So we actually seen a use case around us where still the way that it was solved, that the data problem was solved, was by tagging things manually, actually having teams of humans, of people tagging data or labeling data. So, and that is what we aim to solve with Weaviate. And Weaviate is a vector search engine. Vector search engine because at the core it has language machine learning models. What you will see in the demo, that at indexing time of data, Weaviate will vectorize all the data that you index, which allows you to actually search for concepts. It's completely API based. So Weaviate has a RESTful API and a GraphQL API. We often like to say that the RESTful API is for adding data to Weaviate, and the GraphQL API for getting data. If you are unfamiliar with GraphQL, I believe it has history where it started at Facebook, and now it's part of the Linux Foundation. And it's a very simple, easy to use graph query language. That gives also a little bit away about the data model that you will see in Weaviate. So Weaviate's data model is a graph. You don't necessarily have to make a graph. So in my demo, I'm gonna build a very simple search engine where I'm not gonna really leverage the graph capabilities, but I will also show you some queries where you actually see that in action. Weaviate is often used for automatic classification, semantic search, but also as an infrastructure. So you can actually build your infrastructure on top of Weaviate because it's completely API based. And last but not least, the core is completely open source. So you can basically do anything that you want with Weaviate from the open source perspective. So let me first show you a demo, and the goal that I have with the demo is that I just want to show you Weaviate in action. So if you just Google for Weaviate, that's the easiest way, then often the first result that you find is the documentation. And the documentation is on our website, semi.technology. And at the left-hand menu, you find all the things that you can do with Weaviate, but I'm gonna go for now to the GraphQL query references. Because if you click on one of those references, you see the examples in GraphQL, Python, JavaScript, and curl. However, you also see this green light underneath the GraphQL query. And then if you click here, you can actually run the query that you see there. So this is a demo data set, and this demo data set contains news publications and news articles. And I quickly want to show you the core features of Weaviate in action. So at the root in Weaviate, we have three functions: get for getting data, aggregate for getting aggregated insights, or explore if you want to search through the complete vector space. So then we make a distinction between things and actions, or nouns and verbs, if you will. And then we get to, for example, publication. This class is something that you can set customly. So when I give the next demo where I will build a super small search engine, you will actually see that I set a different class here. This can be anything you want, and it can be as many classes as you want. And the same goes for the properties. In this case, publications have a name. So what I'm saying here is like, get me all things which are publications and show me their name. So if I now run through this and I just scroll to the results. I see here like CNN, Game Informer, Wall Street, New York Times, Vogue, New Yorker, Financial Times, what have you. But what I can do now actually with Weaviate is set a so-called explore filter. So I can say, well, I want to explore for the concept of fashion, and I want to do that with a certainty of 75%. So now the query is still the same. Get me things which are publications, show me the name, but I want you to sort them based on fashion and everything with a certainty higher than 75%. So if I now run this query, you see that it returns Vogue. And as you also see, there's nowhere that the label fashion is nowhere there. So we didn't have to label it ourselves. It did that automatically. But if I would say, for example, well, let's say finance, and I run the same query, then you see here the Financial Times and the Economist. And this not only goes for strings, but also for larger text objects. So let me give you an example there as well. If I say, again, same syntax, get things, but now I'm not going to look for publication, but I'm going to look for article. And I want to see as the title of the article. Then I can say, well, I want you to explore. Oh, excuse me. Let me do that properly. Explore based of the, no. I'm making a typo here. Explore based on the concepts. And let's say that I want to look for the housing market in Asia. And let's not set a certainty, but just limit it to one result. So basically, same question, say, get me all things which are articles, explore them based on the concept housing market in Asia, limit them to one result, and show me the title. So if I run this question, here you see a result. So you see the prime property prediction in 2020 at the right-hand side. And I can, for example, also add the summary. And I will show you in a bit how actually Weaviate used this text corpus to index this data object. What I also want to quickly show you is the graph part. So the graph part is that can be, some people make very simple graphs, some people make complex knowledge graphs with Weaviate. You can do anything, but a simple example here might be, if I say in publication, I can say on publication, and then I can say, show me the name of that publication. And I run this query. You see that we get the same result, but the, oh, apologies. Where was my last query? If we have that last, the graph part, so we have like in publication, and then we see that it's in the Financial Times. So that's a very basic demo. There are many more semantic features and filters, but I wanted to show you the core features in action based on a demo data set, which you can find also through our website. Okay. A little bit about Weaviate under the hood. So what do we actually do, and what kind of capabilities do we leverage to actually get to these results? The easiest way to think about Weaviate is that it's not necessarily a traditional column row based database or a traditional graph database or traditional NoSQL database. Weaviate only stores vectors that represent the data. And if you start an empty Weaviate, you could imagine Weaviate as an empty space. And the first thing that you do, which you will also see in a bit during my second demo, is that you start Weaviate in a language. And these purple dots that you see here represent the concepts in that space. The technology that we leverage for this is called word embeddings. So we just use traditional word embeddings to get to these results. And one of such a purple dot might represent the words publication. Another one might represent fashion. Another one might represent sweater. And other one might represent Vogue. And if you look at those, you see that the distance is kind of logical, right? So there's a relation between Vogue and fashion, that Vogue is a publication, and it's also more logical that Vogue is closer to publication than, for example, the word sweater is. And all those words exist in 300-dimensional space, and they're organized automatically. And what Weaviate adds to this is at the moment that you add a data object, so for example, a publication with the name Vogue, and the articles and the cross-reference that it has, and potential additional data types, excuse me, like a latitude and longitude, it looks at the actual words that you use to store data. So in this case, simply a publication with the name Vogue. It takes those three words, excuse me, and what it does with this, it funnels it down, and on import time, it first calculates the distance between those words in the hyperspace. Secondly, it weighs the words which are more important, and we determine importance based on occurrence in the original training data set. So we say, for example, that the word name is less important than the word folk, because probably folk is occurring less in the training data set. And last but not least, we can add optional word boosting. For example, if you have certain abbreviations or those kind of things. What Weaviate does with this is that it creates a data object, as you see here in the green ball, with its own unique vector representation. And if we now have this empty Weaviate and we add the first data object, you see it adds the data object maybe somewhere here. So now if we query for something like fashion and haute couture, it will actually look in the neighborhood and it will find the data object. And that's how we can near real-time index these data objects and quickly search through them on a large scale. So what I also want to show you is a quick getting started demo. So if it piqued your interest and you would like to try it out for yourself. So I'll go back to the documentation. And the documentation on the getting started, you see the installation tab. There are a handful of ways how you can install Weaviate. One is just if you want to do it locally with Docker Compose, you have a configurator, as you can see here, where you can set certain settings for what kind of Weaviate you want. For example, the language. So default is English, but if you want to have Italian, then now you can set it to Italian. Quick side note, if you want to see other languages there as well, make sure to let us know. You can run this curl command to get the exact compose file you need, and then you run Docker Compose up, and you're good to go. Another way that you can do it is actually in the form of a cloud deployment. So Weaviate is also part of the Google Cloud Marketplace. So it's loading. So what you simply do is that at the top, you select one of the projects that you're working on. You click configure, you set the same configuration, and you have the Kubernetes setup of Weaviate running in your Google Cloud environment. Then we have the cluster service. I'm going to use the cluster service for my demo, which is just a SaaS part, an API part that you can use directly. And then we have, of course, the Kubernetes setup, which I will not go into right now, but it's all on the website. So let's go to the console, where I can get from the button at the right-hand top. And this is my demo. So I'm going to create a cluster. What I just want to say is like this. If you create a sandbox to just play around with it, it's just for free. So you can just, if you don't want to run the Docker Compose locally, you can do it like this. It takes about, well, let's say a minute or 3-4 to actually load. So while it's loading in the background, I continue my explanation. So what you will also find on the documentation are the client libraries, because you can interact with Weaviate in 3 ways. Well, 4 actually. So the first one is through one of the client libraries. So we now have Python and JavaScript. Second one is that you can interact with Weaviate through to curl. So you can just use direct API endpoints to talk to Weaviate. You can also use the console to interact with Weaviate. And last but not least, you could also, of course, write a custom client library if you want to. Our goal is to have more client libraries available in the near future. I'm going to use for my demo, by the way, I'm going to use the Python client library. There are all these how-tos, and there are 3 things that you want to do with a Weaviate. So the first thing is that you want to create a schema. You want to import data, and you want to query data. And those 3 things I'm going to quickly demo to you so that you can see how that works. So if you look at the Python client library, it's just a pip install, which I, of course, done already. So let me quickly set it up. So the first thing that I can do is that I can include import Weaviate, and I'm also going to import JSON because I need JSON to actually visualize. I want to use the JSON library to visualize the results. I need to create a client. So I can say client is weaviate.client. And then I set it to the URL, which I don't know yet because the console is creating one. And just to check that it's working, I can say, well, client schema.get. And then I can say print JSON dumps schema. How do I know that I need to use this? Well, if I go back to the documentation and I go to the schema RESTful API endpoint, and I said get a schema, you can actually see that here's the example that I just typed in. So let's see how so here we have our cluster. So just quickly checking that it works. Well, and it does. So let me set that here. So if I now run this, what I should get back is an empty weaviate, an empty schema. So let's see. Works. So Python. Here we go. And you see it has no actions and no things. So the first thing that I want to do is I want to create a very, very simple schema. And I'm going to do that in the form of a class property object. So class object is. So the first thing that I need to set within weaviate is the name of the class. So in this case, I want to create a document. Next, I need to set a description, which I'm just going to set to nothing for now, just for the demo. Then I need to set vectorize class name. What you might remember, what I showed in my demo here, in my slide deck here, is that we had a publication name and voc. So the question is, do I actually want to index the word, in this case, publication, or in my case, document? And for this demo, I'm going to say no. Of course, in the documentation, you can see exactly why that is and what the functionality is of setting that to true or false. Then I need to add my properties, which of course is an array because I can have multiple properties. And I'm going to say, well, the first name that I want to set is title. So I have a document with a title. Oh, what I actually want to show you here as well in the meantime, if I connect to this weaviate and I try to query it, it basically says like this weaviate contains no schema. So I can't query it yet. That's why we are creating the schema. So I say we have a title. We have a description again, which again goes to nothing, just for the demo. We say which data type it is. So you can set multiple data types. Not like this, like this. For now, I'm just going to demo it with a string. Of course, in the documentation, you can find a list of all data types. And then I have to say, do I want to vectorize not the class name, but the property name. And this. And I'm going to say here false as well. So this is just for the property name title. But of course, the actual text, then I'm going to add. So do I want to index it? Yes, absolutely. Then I want to add a second property. I'm just going to copy paste it, which I'm going to call content. And I'm going to say this is a text object. So now the only thing that I need to do is that I actually need to send it to weaviate. So I can say, well, new class is client.schema.create class. And then we can send in the class object. I'm going to print it. If something goes wrong, the client returns an error message. If nothing goes wrong and it goes well, then it returns no error. So then we should see none. So let's execute this command. You see none. And now if we rerun that previous example, so let's do that quickly, we should see that now this document is part of the schema. And as you can see, it is. So here it is. Now the only thing that we need to do to actually make it valuable is that, oh, by the way, if I now query through the weaviate, you can see, I know I can. So if I say get things, I now see my document here that I just created. And I see the title that I just created and the name. Content that I just created. So if I run this query, it's a successful query, but I don't find anything because, there's nothing. We didn't add any data yet. So what I now want to do is that I want to add 3 data objects. So what I'm going to do is, and the reason I'm doing 3 is because I want to show you how we can easily get to an actual semantic search engine. So data object 1, we need to set the title, we need to set the content. I will do that in a bit. And then I say, well, result 1 is client data object create. And then I'm going to say that's data 1. And what I want to create is the document. And then let's also print the result. The result that it will give back is the unique ID that it has given to this object. I'm going to do this 3 times. So here we have, it's very simple. Point. And now I prepared for this talk some text that I want to show you. So one is about The Simpsons. Oh, so here we have Simpsons, and then we have the content of the article. I have one about the current pandemic, so that the first semester of college hasn't been changed any stranger. Of course, the content that goes with it. And then I have something about cars, about Ferraris. The Ferrari, and then of course the content. So here you go. If I'm going to execute this query and if all goes well, what I should see is basically 3 UUIDs that are returned to me, which represent these data objects. So let's run it. Here you go, 3 data objects. And if I run this query again, we should see those 3 data objects. So let me run this query. And then you see here the article about The Simpsons, the first semester in college, and the article about Ferrari. But now I'm going to go back to Python, because of course, what's the most fun thing that we now can do is actually the semantic search. So what we can do here is that we can set that explore filter. Again, you can find the filters on the website here just in filters. And I can say, well, I want to look for the concepts of, let's say, television show. And I want to do that with a certainty of, let's say, 85% certainty. I'm going to run the actual query. So I say result is client.query.get things. And I want to see the publication. And for now, I only want to return the, not the publication, the document, of course, sorry. Document, the name. I want to add the explore filter with explore, and then I say do, and then that's it. What you might notice in this builder pattern is that here you see the query, and you see get things document name, and you see that here as well. So get things document, and that should not be name, that should be title. It's a live demo, so luckily that I checked, so that should be title. So if I now want to run this query, then let me dump the JSON, make it readable, result, and then we say indent is 2. So what we're going to do now is we're going to get things which are documents, and we're going to display the title, but we're going to add the semantic explorer functionality, because we want to search for concepts based on a television show with a certainty of 85%. So let me run that query. Here we go. And we see we get back the result of the Simpsons. If you now also want to see the actual content, we could do, say like content, like this. So now you see also the content. Or we could also do something else. So we could say, for example, let's search for racing cars and do the same thing. And then we don't see anything. So then let me lower this a little bit. Oh, or let's say race cars. Go. And then we see the document about the Ferrari. So what you do with the certainty is that you actually set this question that I often get. You set the size of this one. So the lower or the higher, the lower the certainty, the bigger the circle actually is. So that's how you can set it. Soon we're also going to release, by the way, a auto certainty, so that it automatically filters the search. Looking at the fact that I have a few more minutes left, there's one more thing that I want to show and want to invite you to check out. Those are the underscore properties. So underscore properties have everything to do with how Weaviate interpreted and semantically classified the data objects. So you can look at interpretations, you can look at semantic paths. So how did Weaviate index it in the store? But you can even use, let's see, feature projection, if you want to visualize, like in this example, your search results. Last but not least, if you go to our website, you can join our Slack channel. You can go to our GitHub page, and it would be great if you can give us some stars because we're almost at 400. So that would be amazing. And last but not least, let's see. I do have. Oh, sorry. That's my last slide. That's this one. If you want to reach out to me, or if you have any questions, feel free to email me, or use any channel. I'm basically Bob van Luit on any channel. Thank you so much for listening. I hope you found it interesting, and I'm looking forward to the questions that you have. Thank you.
Awesome. Thank you, Bob. We do have some questions. I'm going to see if I can curate them in a easy order. First one, which we get with every speaker. Will the slides be available?
Yeah, sure. Yeah.
Okay, awesome. So send them to me, and then we'll make sure to add them to the description in the YouTube video so that people can see it later. Thank you again for taking this time. Okay, so here's some questions. Can you talk about embeddings in 300-dimensional space a little more, please? I'm having trouble understanding what all those dimensions might represent.
Yes. So I'm gonna admit that it sounds a little bit fancy, these 300 dimensions. People who work more with machine learning often see these multi-dimensional representations. And the easiest explanation that I heard to understand why you need these kinds of dimensions is take the following. Let's say that you would go to a restaurant and you order a dish, and you want to index the dish that you're eating based on one dimension. So basically you're saying, for example, is it salty? And if it's 0, it's like not salty at all. If it's 1, it's very salty and everything in between. Now you have one dimension about your dish, but the problem is that's not saying a lot about the dish. It says something, but not a lot. So you added second dimension. So you're going to say sweetness. So now you have one dimension between 1 and 0 about saltiness, a next dimension between 1 and 0 about sweetness. And you can, and then like, for example, you can add a dimension, how is it hot? You can add a dimension, is it big? Was it small? Was it expensive? Was it, well, whatever thing you can think of. And before you know it, you have this whole array of dimensions. And the reason we use them in word embeddings is because if we can just train the model simply on 3 dimensions, and we get just 3-dimensional representations, but it's losing context. It's not good enough. We can't get enough value from those 3 dimensions. If we increase it to about 100 dimensions, 120, we see that it starts to make sense. Then if you increase it to 150 to 300, it makes a lot of sense. And then if you go even to more dimensions, it just it flattens the curve. So that's why those dimensions are used. Now, if I may add one more thing to that, I'm a strong believer that, I mean, of course, I'm extremely biased, but I believe that storing data in the form of vectors, I really believe that will be the future. Because it allows us to not only find data directly, but also do these fuzzy searches like you saw in the example with finding Vogue based on fashion. And there's no reason why we can't do that for images or videos or audio and so on and so forth.
Okay, cool. Thank you. Next question. Okay, this is less technical, but I think it's great that Weaviate is open source. Could you provide some insight into how you monetize open source software, and was it worth it to build it as open source?
I get that question a lot. And I love the question. It's a great question. So now I take off my tech hat off and my business hat on.
Yeah.
So what I learned working in technology is that if you build these kinds of deep technology solutions, if you have a a customer, so a customer opposed to an open source user, is that a customer is not buying a vector search engine. So because they buying a solution to a problem that they have. So for example, I want to search through my documents. And what we do is that the open source license, we just have a very traditional license. That's the BC3 license. But that says, if there's a problem with the software, it's your problem. And that's great for a startup or somebody who's just playing around with the software or those kind of things. But if you are, a big enterprise and you're getting a lot of value from it, you might just want to pay us maybe a little bit extra to that we replace the license, the open source license, with an enterprise license that we can guarantee you an up and running Weaviate. And the reason why we believe that we can do that is because we just believe that the software is good. So, and that brings me to the benefit of open source. I mean, thanks to open source, I can do this, right? So, and people can start playing around with it. We're getting so many people from all over the world playing around with it, asking for additional languages, asking for features, finding bugs, those kind of things. That would just be impossible or I don't know how I would have done that when it was closed source. So it's a short answer to a longer point, but there's an actual strategy of doing this, creating an open source business.
Cool, very good. That's awesome. There's another question with the word open source in it. The console UI that you're using is awesome. Is that open source too?
So the console itself is just running on our server, so it's not open. Thanks, by the way, for saying that. The only thing that the console does is that it connects to the API. So it uses the open source client libraries. It uses open source Bootstrap. It uses open source Weaviate. That's basically the only thing that we're doing. However, what we're going to do is that we're going to allow people to create open source modules for the graphical user interface. How we're going to structure that with open and not, we don't know yet. That's a little bit too early. But if you have any ideas for that, feel free to reach out to me, and then we can figure out what would be best for the community to actually do that.
Cool. All right, a lot more questions. Okay, going back from business to tech, in a multi-language scenario, would we need multiple Weaviate instances? Are there risks to using a single instance when the same spelling of words across languages could have different meanings?
Great questions. So those are two completely different questions. So let me answer them separately. So the one is, the word embeddings that we now use have a single, are for one language. We're also looking into doing it with mixed languages, and there are all types of models that we're looking into integrating. Here, I would also say, if you have a use case of mixed languages, please let me know, because that's we want to, we would like to also help you to see how that might work and how you would use it. In my case, for example, I'm Dutch, and in Dutch we use a lot of English, so we actually see that mixing Dutch and English works actually better. So we're playing around with that. So that's the answer to the first question. The second question has to do with if a word is ambiguous. And one of the, so for example, with Apple, right? So Apple can refer to the company Apple or to the fruit apple. So what we learned very early on was that complaint that people had from a more theoretical point of view, they were right. So they said, like, if we look at the vicinity of that point in space of Apple, we find a mix of things. We find both Macintosh, but also fruit. And that's difficult. What we did, and that was more an engineering mindset, if I may put it like that, is that we said, like, okay, so if I have a data object and I have the word Apple, but I know it's a company, why not move it in the space? Just literally moved in the space. That's what you saw me do with the waiting on import time. That works. We actually have proven that actually works. And one other upside of that is that's fast. So you don't have to retrain the model. You don't have to get a lot of information from the model. You just get a little bit of information. So it indexes very fast. So that's how we solve the problem with ambiguous terms. And last but not least, we have a transfer learning endpoint. So where you can say, well, if I have a specific abbreviation or a specific word or a specific concept that Weaviate cannot know, then you can actually just add it real time to Weaviate, and then for this specific Weaviate, it knows this. And an example there was that we once did something where the abbreviation API should have meant the association for petroleum industries, but of course it knew it as an application programming interface. And you can very easily say to that endpoint, if you encounter API, we want you to index it as something else than the application programming interface. You do that actually with natural language.
Okay, I think you just answered another question. There was a question about languages constantly changing and words take on new meanings, especially in social media. How do you handle changes that occur in the real world? It sounds like you could use that transfer learning call to do that.
Yeah,
okay,
exactly.
Awesome. Here's some other ones. It seems like an amazing service. How much of building it was computer science versus linguistics?
So may I rephrase the question? Sure, I think the question would be, how much was this hacking versus engineering for linguistics? I have to say that the idea for Weaviate really had a linguistic notion, so that I got intrigued by language and how we process language as humans. I don't have a background in this, so I probably reinvented the wheel that somebody else already thought of like 100 years ago. But I got this notion that I thought like, hey, if we have these words in space, what would happen? And this is as simple as it sounds. That was actually the idea. Like, what would happen if I take a small text corpus, like what you saw, for example, that document about The Simpsons? I look at these individual words, and that's what I place in that space. Does that give me new context? Because if the special idea works of in placing data objects in space, and individual words in space, and then I just add a data object there as well, would that work? Can I then find it by searching for Marge from The Simpsons or by television show, etc., etc.? And the answer is actually yes, that works. So to give a serious answer, it was absolutely inspired by linguistics. I know, no doubt about it. It soon went into the combination of the hacking realm, like, can we actually do this? And now for like 1.5 years or something, or no, not 1.5 years, but a year or something, really in the engineering realm. So how do we scale this? Our ambition is really to go to Google sizes. If I may give a suggestion, there's a YouTube video from somebody in my team. If you YouTube for Weaviate and HNSW, so let me quickly write that down. You find an exact 45-minute video about how Weaviate is working under the hood and how we scale it and which algorithms we use, if you're interested in that. It's on YouTube.
Is that the one with Etienne?
Yes, that's correct.
I'll go ahead and add a banner real quick. It's kind of big, but
yeah, but that's cool.
Let me see. I can make it a little better because we don't need the whole thing. There we go. Oh, didn't save the change. Okay, I'll read the next question while I'm working on that.
Yeah.
There we go. Okay. It looks like Weaviate is built in Go. Was that a personal preference or for speed?
The latter one.
Okay. Easy question. Go ahead. What?
No, the answer is yes.
Yeah. If we're already using other tools to power search, is there an easy migration path?
That's a good question. So we really haven't encountered difficult migrations yet. So for example, how people currently use Weaviate is the easiest one is like if they use it as their infrastructure, but we see that people use it with SAP. If people use it next to other existing search engines. What we often see happening is that people just rewrite the import scripts. It's a little bit simplistic answer, but that's what we currently see. We haven't encountered a situation yet where people say like, okay, we now just we need to pump an X amount of gigabytes from A to B. We haven't encountered that yet. So unfortunately, I think I can't give a satisfying answer to that.
Okay, and that's I'm glad you said that because I think I have two questions that are directly related to what you just said. So the first is, I noticed you called create individually on each object. Do you support bulk operations?
Yes, absolutely. Yes.
Okay. And the second one is this is very specific. Which endpoints do you use for transfer learning? Your example of API being transferred to American Petroleum Institute instead of application programming interface.
So let me, you know what? Let me send you that URL. It's
Sure.
I can find it very. It's on something which we call the contextionary endpoint, and the reason we call it contextionary, it's a wordplay on dictionary, of course, and that's where the context that we've has sits. It's a little bit of a long URL, but if you are in our documentation, look at the RESTful API references, click here you go, click contextionary, and then extending the contextionary. Can't miss it.
Okay, great. Let's see. I thought there was one more. Looks like we covered this one. Is about migrating from like Power Search, but we talked about that. Oh, here we go. Yes. What is the minimum amount of existing data needed to really get meaningful results in search?
Well, hopefully I just demoed to you that only having 3 data items in there already gave meaningful results. So, well, I hope that I proved that the answer to this is not a lot.
Yeah, awesome. It definitely did. Very cool. Thank you so much. So we'll keep taking questions on our forum. And if there's any others that come up, we'll share them with you and eventually share it with our community. And I recommend everyone go out and try it out.
Thank you so much. And again, people, if you have any questions, feel free to reach out. Thank you so much.
Thank you, Bob. Have a good night.
Thank you. Bye-bye. Cheers.
Bye. All right, everyone. So we'll be wrapping up soon. Let's go ahead and bring up the raffle slides again. If you haven't entered yet, please enter the raffle. We'll do another 2 drawings in our remaining time. Looks like we got a couple more people that entered. So I'll give you some time to fill that out. Also, feel free to continue submitting questions. We'll pass them on to our guests. If they're not ones that we can answer, then get back to you and post questions and answers on the channel. Just a reminder, today's event is brought to you by the various chapters of GDG chapters in the Pacific region. This is a small set of the chapters that we have in the region. There's actually a much longer list that you can find by visiting gdg.community.dev. And there you can join your local chapter as well as any other chapter around the world. We hold events all the time, different topics, different subjects. So I highly recommend visiting the site frequently to see what's coming up on the agenda. And yes, we will paste URLs. There was a question that came up. We will paste URLs in the YouTube chat. It's hard to multitask, but we'll make sure that they're all there for posterity on the recording. We can also put them in the description too. Thanks for the question. Last chance to enter the raffle. About to do another drawing. Just as an FYI, in case people are paying attention to the numbers very closely, I went ahead and took the winners out of the list and then renumbered. So if you see number 11 now and you didn't see it earlier, it's no funny business. I just reordered. All right. So let's go ahead and pull up our wheel. And I'm going to actually share it so that we can hopefully get some sound too. So 1 second while I do that. There we go. All right, let's spin the wheel. Oh. Oh, wow. It jumped the next drawing. So 39 is Adam. Adam, we're going to contact you via email afterwards and let you know that you won a prize. Let's go ahead and remove that number. And we'll do another drawing. 66, that's Steve B. Steve B, congratulations. You're our 7th prize winner. We'll keep the form up, actually, for a little bit, because some people are going to be watching this async since we're live streaming. So we'll keep it up, and feel free to continue entering the raffle, even if you're watching this later, after the live stream's over. We'll do our best to send out as much swag as we can. And again, we'll notify winners via email. Let's pull back our slides. 1 second. Here we go. So enter again. Tell your friends to come watch on our channel. They'll still have a chance to enter the raffle too, and possibly win a prize. Feel free to still submit questions if you're watching this and playing with these tools at home and you have a question. Submit them. We'll pass them on to our speakers. And any other questions, if you want to get involved, we have GDG chapters all over, but we also are welcome of new community organizers if you want to start one in your community too, or help out one that already exists. Again, the URL is GDG. Where'd it go? There it is. Oh yeah, it's up already. gdg.community.dev, where you can find all the chapters around the world, and you can at this point help out anybody because we're all virtual. So thanks again for attending. We hope you enjoyed it, and we look forward to seeing you again soon. Take care.